Hi and hello dear friends, welcome back once again to our channel VAAGAI Academy of Mathematics, and this playlist is where you can find video lessons for CBSE Class 11 Applied Mathematics, and we are solving exercise problems from our standard book ML Aggarwal, Neeraj Raj Jain. Following it, this session we are about to solve exercise 2.3, which is from the concept of indices and logarithms. Already in this concept, we have already completed the first two exercises, exercise 2.1 and 2.2. We have already completed them, and there we had all those basics of what about indices, the rules of indices, and also we saw about the basics of logarithm and everything. And here as an extension, exercise 2.3, we are about to solve problems which are based on standard rules of logarithms. This is all the problems which are based on this exercise is going to be. Alright, okay. So this is going to be the objective of this session. We are about to solve exercise 2.3 from our standard book ML Aggarwal, Neeraj Raj Jain. And before we get into solving the problems, we need to see some basic, very important standard rules of logarithms, okay, which is what I've listed here. So we'll have a view of what are all the rules which are there, and only after seeing these rules, these laws, we'll be able to solve the problems from this exercise. Okay, all right. So in that way, let us have a quick view of what are all the rules we have here and how we have to use them. Everything we'll have a quick view now itself. Okay, yes, yeah. Here I've listed the rules. Let us see them one by one, starting from the first standard law of logarithm. Okay, the first law says log of m to the base a plus log of n to the base a is equal to log of mn to the base a. This is the first rule. Okay, so we'll have to see the meaning also. All right, okay, that is log of any two values, they have the same base. Remember, log of, there are two numbers, there are two values and they have the same bases. What happens is, if they get added, then what will happen? See the right hand side, it will be log of the two values will be getting to the product. Okay, they have to be multiplied and it will again have the same base. This is what the first rule says. Okay, yes, so log of m, the first value, to a base a plus log of n to the same base a. When we add them up, what happens? It will become right hand side log of mn, I mean the logarithm values, they both will be getting multiplied. Okay, we'll have to take the product again, the log will be of the same base a only. Okay, this is the first rule. We'll call this rule as what? We'll call this as the product rule. Okay, I'll just write it here. So this is called the product rule. Okay, product, I'm writing it here, product rule or product law, we can call it like this. Okay, now second one, this one says log of m to the base a minus log of n to the base a is equal to log of m divided by n to the base a. Okay, this is what is the second law. Okay, so I hope you will be able to understand the second one. It's going to be very easy. It's going to have a very small change only. Okay, so when we have two logarithm values having the same basis, when we minus them, okay, when we minus them, then what happens on the right hand side? Here it will be getting divided. Okay, m divided by n. That's what happens in this second law. Okay, so the first law says when they are added, the logarithm values get multiplied, but when they are subtracted, the logarithm values get divided. Okay, this is what it says. Okay, so this second law is what we call it to be the quotient law. Okay, quotient rule or quotient law, this is what we call it. Okay, yeah, coming to the third law, this one says log of m to the power n to the base a. Okay, log of m power n to the base a will be equal to, it's a very simple law. Okay, what happens is this power n, here it is there, right, the power n which is raised to this m, this power n comes to the front. Okay, this becomes n times of log of m to the base a. This is what happens. Okay, this is what this third law states. Okay, so what happens? Very simple adjustment we are doing here. Log of m power n to the base a, what happens is the power comes to the front and it will become n into log of m to the base a. This is what it becomes. So this is like n times of the logarithm of m base a. This is what it means. Okay, so since we play with powers here, this law is what we call it to be a power law. Okay, this is called the power law or power rule of logarithm. Okay, yes, So yeah, the first three are going to be very standard, very important. Okay, so these are going to be the first three things, and they are the names called product law, quotient law, and power law. Okay, yes, I hope it is very clear to you. And coming to another important law here, this one, what this one states is, this one states log of m to the base a. Okay, this is something like an expansion. Okay, so according to our comfortability, it is based on the convenient thing. Okay, how we have the problem. Okay, so based on that, we'll have to be using this law. Okay, log of m to the base a is equal to, okay, this can be written as what? This can be written as log of n to the base a multiplied by log of m to the base n. Okay, you may wonder what is happening over here. Actually, it's going to be very simple. Okay, what happens is log of m to the base a. Okay, log of m to the base a, what happens is we are inserting another value. Okay, we are inserting another value here, we are introducing another value here, which is n here. Okay, so what happens is that n I can take here. Okay, now see here, log of n base a times log of m base n. Now what happens is, just try to multiply these two values. Okay, when you try to multiply these two values, you will again come to get this value only. Okay, let me tell how it works. Okay, it's going to be very simple. See here, the first value, this first term, here we have log of n to the base a, here we have n here, correct, and here log of m to the base n, here we have n here, correct. So that means here the value n is appearing for the logarithm value, and here the n is appearing at the base. Okay, so what happens is they both will be like getting cancelled. Okay, they both will get cancelled. So you can just imagine here. Okay, you can even hide it and then just you can imagine. Okay, I'll just hide it and show you, so that will be easy for you to understand. So you can just hide it and like this, and now you can see. Now what happens is you will be able to see only log m to the base a. Okay, this is all you will be able to see now. Okay, log m to the base a. So that is what is here, you can see, right? Okay, yes, I hope now you are able to understand this. Okay, so yeah, these are all going to be very important things, and this law is what we call it as change of base rule. Okay, we call this as change of base rule, change of base rule. Okay, so we call it as change of base rule, and with its application also we have other things. Okay, we also have other things also. Okay, so what happens is, so let me just try to show you what will happen. Okay, I'll just have other ideas also, other things also we'll be able to deduct from this. Okay, I'll show that, but before that we'll just go through other few basic things also. See these two things. Okay, these are also very frequently used things. Okay, so what are these things? Is log of a to the base a is equal to 1. Okay, log of a number to its same base will be always equal to 1, and log of 1 to the base a, log of 1 to the base any value is going to be 0 only. Okay, I think this from the previous exercises itself we will be able to recognize this. Okay, because previous exercise 2.2 we saw all the basics of logarithm. From there itself we can understand the idea or understand how these things are coming. Okay, so these are going to be very frequently used things. Anyways, here also we may happen to use them. That's the reason I've written these things also separately. Okay, now keeping these things in mind, okay, keeping this in mind, I'm going to detect some other things from this change of base rule. Okay, just carefully see what I'm going to do here. Okay, I'm just going to do a small replacement. Okay, I'm just going to do a small replacement. What I'm going to do is log of, okay, log of, I'm going to take this m as just I'll take it to be a itself. Okay, I'll just try to take this m as a itself. Okay, let me just see what will happen if we take this m as a. Okay, so we'll just try to see what will happen. Okay, so I'm going to take this m as a. So what happens is log of a to the base a will be equal to, and here what will happen is log of n to the base a multiplied with, here it will become log of a to the base n. I hope you are able to understand this. Okay, I'm just doing a very small replacement here. I'm just replacing this m as a. So what is happening is log of a base a is equal to log of n base a into log of a base n. So wherever m comes, I'm just going to replace it as a. That's it. Okay, so wherever m comes, so I'm just taking this m is equal to a. That's all I'm doing here, and hence I'm getting this step. Okay, now see here, this left hand side is what? Log of a to the base a. Is it or not? So log of a to the base a is nothing but what? It's going to be 1, correct? So that means what you can understand here is log of n to the base a multiplied by log of a to the base n is always equal to 1. Okay, so this also we'll be able to detect. Okay, so this thing also we'll be able to detect from this change of base rule. Okay, so that is log of a value with some other base multiplied with, when we reverse it, when we invert it, okay, that is log of the base value that comes here and the actual value comes to the base. Okay, when we do this kind of replacement, the product will be equal to 1. Okay, yes, so this way also we'll be able to detect it. Okay, yes, fine. And as an extension, what I can do here is not an extension, just I can just do a very small replacement. What I can do is like I can just change the position. What happens is like this log of a n to the base a can be written as what? This can be written as 1 divided by log of a to the base n. That is log of n base a is equal to 1 by log of a base n. Okay, this also we can tell. Okay, so this is coming from where? This is coming from this step only. Just a small just adjustment here we are doing. I'm just taking this into value to the other side. It becomes 1 divided by. Okay, that's what is happening. So what happens is like log of a value with some base will be equal to 1 by, we can just interchange the positions of the value and then the base. Okay, this is what it says. Okay, so these are all very important axioms we need to just know in order to solve the problems that are from this exercise 2.3. okay, so I'm requesting you to kindly take a note of all these rules and laws, everything. Okay, so that it will be easy for us to use them in the problems which you are going to solve now. Yeah, take a moment to copy all these things. And yes, now we'll get into the problems. Starting from the first question, here we got 4 subdivisions. Here we need to simplify the given following expressions. Okay, yeah, fine. So the first subdivision here we have log a power 3 minus log a power 2. So this is the first question. Here we need to simplify this logarithmic expression. Okay, yes. So first of all, let us see what rules here we can use in order to simplify this expression. Okay, yes. So we can first of all try to use the quotient rule. I mean the second rule, is it or not? Because we have log of some value minus log of another value. This is how we have. So when we have log of m to some base minus log of n to some base, what we can do here? We can use the quotient rule, is it or not? So when we use it, what happens is this becomes log of, the values will be getting divided, is it or not? The first value a cube divided by the second one, which is a power 2. We can divide it like this with the same base. Okay, here the base is actually not defined. Okay, when the base is not defined in logarithm, what happens? It is, we call it to be common logarithm. Okay, that is, there is a base 10 there. Okay, but anyways it is not specified. We also not specified. Okay, so if it is not specified, it is understood that it is a common logarithm and the base is 10 there. Okay, so if the base is specified, we will also write the same base here. If it is not specified, nothing wrong, nothing mistake or nothing wrong, we need not also define the given base there. Okay, so we need not define the base missing here because it is understood that it is common logarithm. Okay, yeah, fine. So anyways, coming back, we have log of a power 3 divided by log of a power 2. This is what we have. So this will be equal to log of, what about a cube by a square? What happens? So I can cut a square with this a square. I will have one power here, right? Is it or not? So that means I will have a power 1 here, correct? Is it or not? So that means I will have log of a power 1, which is going to be log a itself. That's it. Okay, so that means the simplified expression for this question is going to be log a is the answer. Okay, yes. Yeah, this is one approach in which we can do the problem. We can even use another approach also. Okay, this is the first approach. We can even use another approach here to solve the same problem. What we can do here is we can here use the power rule. Okay, we can use the power rule. Why? Because we have the logarithmic value raised to some power. Is it or not? So what about the power rule? What happens to the power when we have the value raised to some power? What we will do there? So for example, log a power 3, we have it like this. So what we can do here is I can bring this 3 to the front. Is it or not? So that it becomes what? This becomes 3 log a. Okay, 3 log a minus, we'll have the same minus here, and log a square. Here we have the power as 2, and here also what happens, the power 2 will come to the front, so it will become what? 2 log a. I hope you are able to understand this. Okay, so this becomes either 3 log a minus 2 log a. Okay, this way also we can simplify. Okay, so all right, so yeah, done. So that means 3 log a minus 2 log a. So how we can simplify this? This is like some 3x minus 2x. But in the place of x, we got log a, that's it. Okay, so 3x minus 2x will be what? Simply it will be x, correct? It will be 1x or it is x, simply x, is it or not? So that means if it is x means what happens? It is like log a only, the value, the log a itself will come here, okay. So however, in whatever approach we try, the answer is going to be finally log a is the answer, okay. So log a is going to be the answer for our first question, first subdivision here for this question, okay. I hope it is clear to you. Yeah, now coming to the second subdivision here, okay. Second subdivision, what do we have here? Here we have log a power 3 divided by log a power 2, okay. Yes, fine. See, one thing we have to be remembering very carefully, okay. Here is where students usually they will fall in the traps, okay. So we have log of some expression plus log of some expression, or log of some value minus log of some value. When you have the logarithm values, when they are added or subtracted, only we can use the rules, I mean the divisibility, I mean the laws of logarithm, okay. Sorry, the laws of logarithm that we can use, okay. But here we have division sign, okay. So when we have division sign, we will not be able to directly use the laws, okay, because defining this division or defining multiplication, we don't have any laws, okay. So for multiplication or division, we have the change of base rule, that is okay, but apart from that, we don't have any special laws here in the standard way, okay. So in that case, what we have to do is, we will have to try using some other things only, okay. Yeah, we'll go for this one. So this can be written as, like how we used the second approach to solve the first question, let's use the same approach here. So here we have log a power 3 divided by log a power 2. This is what we have, right? So what I can do here is, I will bring the 3 to the front side, that is I am going to use the power rule, okay. So when you use the power rule, what happens? This log a power 3 will become 3 log a divided by, now come here, we have log a power 2. So this will become what? It will become 2 log a, okay. I hope it is clear to you. So this is like 3 log a divided by 2 log a. I can in turn write the same expression like this, right? So I can write as 3 log a divided by 2 log a. I can just write as a fraction, is it or not? I can still do that, right? So when I try to do that, I will be getting my expression like this, 3 log a divided by 2 log a. And so what happens? So I can now cut log a and log a. So this will simply give me 3 by 2. So that means 3 by 2 is going to be the answer for our second subdivision, okay. I hope that is also clear to you. Now coming to the third subdivision, okay. Here we have numbers, okay. Third one and fourth one, if you see, we have got numbers, okay. So here we got some a square algebra terms, but here we have numbers, right? So how can you simplify these kind of numbers based calculation? That also we will see now. So here we have log 4 divided by log 2. This is what we have, right? Okay. So here for this kind of thing, the approach what we have to take it in our mind is, the approach what we have to plan is, we will have to plan in such a way that we need to express, we will have to try to express the values using the same exponents, okay. I mean the base raised to some power, that way we are writing, right? That base is to be same, okay. Not the logarithm bases, okay. They are same only. I am talking about when we try to write as an exponent, that base should be same. In that way we will have to try to express, okay. Or in other words, if I want to tell in a simple way, we will have to try to express them the powers of the same numbers. That way we will have to try to write it, okay. So for an example, we have, see here, we have here log 4 divided by log 2, right? Okay, here we have 4 and here we have 2. Now think of a number with which we can write. I can write as 2's powers, is it or not? I can write this 4 as 2 power something, yeah, okay. And this 2 as 2 itself, okay, because 2 is simply like 2 power 1 only, right? Is it or not? So I can write as 2 itself, but this 4 I can write as 2 square, okay. Let's just try to do what will happen, okay. Let's just try putting it like that and let's see how it follows, okay. So log 4 I'm going to write as log 2 square, okay, log 2 square divided by log 2, okay. I'm going to write like this. Now what will happen is, I'm going to use the power rule now, okay. Let me use the power rule now, that is log 2 square. What happens? This power 2 will come to the front, so that it will become 2 log 2 divided by log 2. I hope it is clear to you. This step is also very clear to you, okay. So I'm writing this log 4 as log 2 square, and in turn I'm bringing this 2 to the front side, okay. I'm using the power rule, that's it, okay. So that this becomes 2 log 2 divided by log 2. Now it's going to be very simple. I can now cut this log 2 and log 2. So I'm simply left with 2. So that means the simplified form of this third subdivision is going to be 2 is the answer, okay. Yeah, coming to the last subdivision, the fourth one, here we have log 27 divided by log root 3, okay. So here is another very good question. So log 27 by log root 3, okay. Here also we need to try to use the same approach, okay. Let's try to write them using the powers of the same number. Okay, so see here we have 27. Okay, and here we have root 3. So both are going to be powers of 3 only, is it or not? So let's try to write them as power of 3, power of 3. Okay, let's try to do that. Okay, let me just show you what will happen now. So this is going to be equal to log of this 27. I'm going to write it as 3 power something. You can tell me what is 3 power? 3 power which number will give you 27? It's easy, right? It's not 27 is not a very big number. So 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is what is 27, is it or not? So that means I can write this 27 as 3 power 3 divided by, now come here to the denominator position. Here we have log of root 3. Okay, so how can I write this root 3 now? So log of, how can I write this root 3? This root 3 you have to use, try to write it as 3 power something. Okay, so I'm going to write this root 3 as 3 power what number? You just think and see. We have already seen all these things in our previous exercises itself. Exercise 2.1 itself, we tried to solve more problems there. We tried many problems based on this exponents and everything. There itself we saw about all the rules of exponents and everything. So hope you are clear with all those basics and everything. And yeah, I'm insisting now itself, if you have missed those videos, kindly see those videos. Okay, so that will be easy for you to follow the problems that we solve here in this exercise. That's the reason. Yeah, coming here, this root 3 can be written as what? Root 3 is actually what? It is going to be 3 power what? It's nothing but 3 power half. Is it or not? All these things we have seen there itself, right? Okay, 3 power half I can write like this. Now again I'm going to use the power rule only. Okay, I'm going to use the power rule. So it becomes what? This log 3 power 3. This will become, this power 3 will come to the front. So that will become 3 log 3 divided by, same way here also we have 3 power half. This half will come to the front. So it will become 1 by 2 log 3. I hope it is very clear to you. So log 3 cube I am writing like this, 3 log 3, and log 3 power half I am going to write like half of log 3. Okay, half log 3. Okay, just using the power rule, that's it. So the values, the powers will come to the front. Okay, now as usual I can just cut this log 3 and log 3. So I will be simply left with 3 divided by 1 by 2, which is nothing but what? This is going to be nothing but this 2 I can bring into the numerator position. It will become into 2. So 3 2s are, the answer is going to be 6. So 6 is going to be the final answer for this subdivision. Okay, I hope everything is clear to you. All the problems are very clear to you. You are just using the basic rules, the standard rules of logarithm only. So here, so kindly take a note of all those rules. I have just started with that rules only. So kindly take a note of those rules. When you come to use it frequently, you yourself will be getting memorized with the rules. Okay, you need not try to mug up or you need not by heart it. Just try to struggle. You try struggle a lot and then by heart it. Once you try to use it for some 5 or 10 questions repeatedly, you yourself will be able to memorize it. Okay, very easily it will feed to your mind. Okay, that's it. It's going to be a very simple process. That's it. Okay, yeah, fine. So using those rules are what we are solving all these problems. I hope the first problem is the first question. All these subdivisions are very clear to you. Now let's move on to the second question. Let's move on to second question. Here we have the first subdivision. Here we need to evaluate the following, right? Okay, so we need to simplify and then we have to evaluate the values. This is what we are expected to do. So coming to the first subdivision of the second question, we have log of 10 divided by cube root of 10. This is what we have, right? Okay, so now what we can do is like this can be written as log of 10 divided by cube root of 10. Okay, cube root of 10. I'm writing like this. And next step what I'm going to do is log of, I'm going to write the 10 as this 10 as 10 power 1 divided by this cube root of 10. I'm going to rewrite it as 10 to the power 1 by 3. I hope you know the reason why it is. This follows from the axioms of that exponents itself, right? Okay, so we have already seen the laws, the exponents, right? Laws of exponents, right? There itself we saw the laws or axioms of these exponents. So we can write like this. Cube root of 10 I'm writing like 10 power 1 by 3. Okay, all right, yeah. Next what I can do here is log of, what about this 10 power 1 divided by 10 power 1 by 3? What happens to this step? Now what I can do, I can just divide it, right? So when you divide it, what happens? The powers will be getting subtracted, is it or not? That also we know that. So 10 power, this will become 1 minus 1 by 3. So this will simply become log of 10 to the power. What is 1 minus 2 by 3? Sorry, 1 minus 1 by 3. What about 1 minus 1 by 3? It's going to be 2 by 3, is it or not? This is going to be 2 by 3. And now I can use the power rule. Okay, log of 10 power 2 by 3. I can use the power rule of logarithm. I can bring this 2 by 3 to the front so that it will become 2 by 3 log 10. Okay, this is how it becomes. And last, just one more step. What about this 2 by 3 into log 10? What about this log 10 alone? Log 10 means it is a common logarithm, right? So the base will be 10. When the base is not specified, not mentioned, we need to take the base as 10 itself. Okay, this is what we call it to be the common logarithm. And what about log 10 to the base 10? It's going to be simply 1. Why? Because log of a value with the same base is going to be always 1, right? So that means 2 by 3 into this value will be nothing but 1. So we will have 2 by 3 times of 1, which is in turn 2 by 3 itself. So this 2 by 3 is going to be the answer for our first subdivision. Okay, I hope it is very clear to you. Just a basic format only. So we have to carefully follow the steps. We'll be able to easily achieve the answer. Okay, now coming to the second subdivision here, we have 2 plus, okay, I can write as 2 plus, here we have 1 by 2 times log of 10 to the base minus 3. Sorry, 10 to the power minus 3. Okay, we have 2 plus 1 by 2 into log of 10 power minus 3. Okay, so the first step what I'm going to do here is I'm going to use the power rule. Okay, when I use the power rule, what happens? This minus 3 will come to the front. So remember, this minus 3 will come to the front. So it will become what? This minus 3 will become here, will come here. So that means it will become minus 3 by 2 into log 10. This is how it becomes. I hope you are able to follow it, you are able to understand it. We already have 1 by 2 here. We had 1 by 2 here. So this 1 will be 1 itself. But this log of 10 power minus 3, this minus 3 will come to the front and it will become like minus 3 divided by 2. Okay. So continue 2, and what about this one? This plus into minus will become minus. So 2 minus 3 by 2 into, what about this one? This is log 10, and again log 10 will be as usual what? It will be as usual 1 only, right? Here itself we saw the reason, right? Because it is a common logarithm, the base is not defined. So whenever the base is not defined, the base is going to be default way, it is going to be 10 only. So it's like log 10 to the base 10. So it is simply 1. Okay, so it's going to be simply 1. So it is like 2 minus 3 by 2. So 2 minus 3 by 2 into 1 will be 3 by 2 only. So 2 minus 3 by 2. So what do we have now? We can take the LCM. So we will be getting it as 2 2s are 4 minus 3. So the answer will be 4 minus 3, which is 1 by 2. So 1 by 2 is going to be the answer for our second subdivision. Okay, hope this question is also clear to you. Coming to the third question, we have a little lengthy question. Okay, we have a very lengthy expression given here. We should carefully solve this and evaluate the value of this expression. Okay, so carefully follow the steps. Okay, first of all, let us just go through the question once. So here we have 2 into log 10 power 3 plus 3 into log 10 power minus 2 minus 1 by 3 into log 5 power minus 3 plus 1 by 2 into log 4. This is all we have here. Okay, yes. So I hope it is very clear to you. The question is clear. So now we will carefully transform the steps. Okay, so we'll do it step by step. Carefully we'll do the steps. Okay, so what I'm going to do here is the first step. I'm going to use the power rule, as usual power rule. Okay, let me try to bring this 3 to the front. So I'm going to try taking this 3 to the front side. Okay, so that it will become what? It will become, already we have a 2. Okay, we have a 2, already we have a 2 here. So once this 3 comes to the front, it becomes 3 into 2. Okay, 2 into that 3. So this will become 6 log 10. I hope you are able to understand this step very carefully. Okay, I'm just simply using the power rule. So what happens is this 3 which is in the power will come to the front. So when it comes to the front, it becomes 2 3s are 6 and log 10. That's it. Okay, very simple adjustment is what we are doing here. Next, okay, what we can do here is, let me use the same thing. Let us try to do the same operation here for the second expression also. Just look at this carefully. Okay, so what happens is, like here we already have plus 3 into log 10 power minus 2. Let us do the same thing here. Okay, let us try to bring this power, that minus 2 value, to the front, so that it will become what? This becomes what? Already we have plus 3 into minus 2. It will become plus 3 into minus 2, which is nothing but minus 6, right? So it will become minus 6 log 10. Okay, so I hope the first two operations are very clear to you. Here we did 2 3s are 6 log 10, and here we did 3 into minus 2, which is minus 6 log 10. Okay, this is what we are doing here. Yeah, continue. Next, what we will have here also, we'll try to do the same thing. Okay, let's try to do the same thing. So what will happen here now? So here we have a minus 3 in the power, right? We already have minus 1 by 3 log of 5 power minus 3. This is what we have. Now I can again bring this minus 3 to the front. Okay, be careful. I can bring this minus 3 to the front so that it will become what? This is already minus 1 by 3, and when I bring this minus 3 to the front, it will become minus 1 into minus 3. So be careful with the signs also. This is minus 1 into minus 3. It will simply become plus 3 divided by 3 and log 5. This is what it becomes. Okay, I hope you are able to follow this also. I'll repeat this. So minus 1 by 3 log 5 power minus 3. This is what we have. This minus 3 simply I am bringing to the front. So it will become minus 1 into minus 3, which is going to be plus 3 divided by 3. Okay, this is what happens, and log 5, this is what we have. And what next I am going to do here is I am going to do a small adjustment here. Here we have 1 by 2 into log 4, right? Here alone I am going to do a small adjustment. What I am going to do is I am going to write this as half into log of that 4. I am going to rewrite as simple 2 square. I am going to write as 2 square. Okay, I have a reason, right? I have a reason. I will reveal that. So that 4 I am going to replace it as 2 square. Okay, yes, fine. Yeah, now continue the steps. What next we can do is, now you can easily visualize here, right? 6 log 10 minus 6 log 10. Okay, you can easily see that, observe that. You can cut these two terms because this is same terms. Okay, plus and minus. 6 log 10 minus 6 log 10, they will be cancelling. Okay, so we'll be simply left with these two terms only. Is it or not? So we will have 3 by 3 log 5 plus 1 by 2 log 2 square. Okay, this is what we will have. And again this 3 by 3 also we can cut it, right? So I can cut this 3 by 3. So I will have simply log 5 plus, next what do we have here? Here we have 1 by 2 log 2 square. Okay, now the reason why I wrote this 4 as 2 square is I will again try to use the power rule. That's it. That's simple reason. That's it. Okay. Now I will use the power rule once again so that I can bring this power 2 to the front. So when I bring this 2 to the front side, what it will become? It will become plus 2 by 2 because we already have a 1 here. Okay. So this is 1 into that 2. That 2 will come here, right? So it becomes 1 2s are 2 by this 2. So 2 by 2 log 2. This is what it becomes. Okay. Simple, very simple. Okay. So now log 5 plus, what about this 2 by 2? This 2 by 2 I can cut it. Okay, I can cancel this. So I will have log 2. So finally I got log 5 plus log 2. This is all I am left with. Okay, fine. So this is going to be the simplified expression. Still, now also I can use the which rule? We can again use the law of logarithms, right? The first rule we can use. The first rule is nothing but the product rule, right? Log of one value plus log of another value when they have the same basis. What we can do here, when we have the same basis and the logarithms are getting added, what we can do? We can take the product, right? Okay, log of, we can take the product. Product means 5 into 2. I can multiply these two logarithmic values, right? Okay, so log of 5 plus log of 2 will simply become log of 5 into 2. That's it. Okay, this is what the first rule says, right? So that's what we are using here. Okay, so what happens is like we will have log of 5 2s are is going to be 10. Simple, right? So log of 10, and what about log of 10? Log of 10 is as usual. This is going to be 1 only, right? We have already seen the previous questions also, right? The first question also we happen to get log 10 there, right? So log 10 will be what? Again, as usual, it is going to be 1. I also stated the reason why log 10 is 1. I stated the reason. It is very simple, right? Because this is common logarithm. Okay, log 10 to the base 10. So when we have same base and logarithmic value, the value, simplified value is going to be 1. So that means log 10 is going to be 1 is the answer for our third subdivision. Yeah, take a note of all the 3 questions. I hope you are able to follow this. Next, we'll go for the next subdivision. We have 2 more subdivisions from question number 2. Subdivision 4 and 5. These 2 questions are going to be little different when compared to the previous questions. Okay, so we're going to handle a different kind of approach to solve these 2 questions. Okay, fine. Yes, different in the sense not going to be very much complicated, but this needs some different kind of approach. That's the reason. Okay, yes, but still we are again going to use the same laws of logarithms only to solve these questions also. So listen carefully how we are going to deal these 2 questions. Okay, yes, so even if you are going to miss it at any moment in between, it will be very tough for you to catch and follow the further steps. So be careful, carefully listen the steps how we are going to arrive and get the answer. All right, okay, yeah, we go. Now coming to the 4th subdivision of the second question. So here we have the question as 2 log 2 plus log 5 minus half of log 36 minus log of 1 by 30. So this is what we have here. Okay, all right. Yes. Now what I'm going to do is I'm going to write everything as log of some terms. Okay, I'm going to write all these terms as log of some value. Okay, this is how I'm going to express all these terms. Okay, see how many terms are here. There are totally 4 terms are here, right? 1, 2, 3 and 4. Okay, all these 4 terms I'm going to write as log of some value. This is what I'm going to do. Okay, fine. Yeah, first term coming here, we have the first term which says, here we have 2 log 2, right? So this 2 log 2, how can you rewrite it as just log of some value? Can you just think of this? How can you rewrite this 2 log 2 as log of some value? How can you do that? It's going to be very simple. We need to use again the power rule only, right? Okay, we can simply use the power rule. Very simple. You can use the power rule. Okay, so see here 2 log 2 is there. Like how we used power rule in the previous questions. We had the power value here. That power value we took it to the front. Okay, now we are going to use the reverse way. Okay, same power rule. I'm going to use the reverse way. How I'm going to use it? I'm going to take this value which is in the front. I'm going to take it to the power. Right? Okay, able to understand this? I have 2 log 2 here. How I'm going to rewrite it? I'm going to write this as log 2 to the power 2. Okay, that is this 2 will go to the power position. Okay, this power 2. Okay, here it will come here. Okay, so this becomes log of 2 square. This is what I'm going to do. Okay, this adjustment is what I'm going to do here. Okay, I hope now you are able to understand this. Okay, so power rule is what I'm using. So now this term became log 2 square. Okay, simple, that's it. Okay, plus now here we have what? We have log 5, right? This is in terms of log of some value only, so no need to change it. Okay, let this term be as it is. Okay, log 5, let us have that term as it is, no issues. Okay, yeah, next coming here, minus 1 by 2 of log 36. Okay, now also I'm going to do the same thing. Okay, now what value I have in the front, this 1 by 2, I'm going to take it to the power of this 36. Okay, I hope you are able to understand it. Okay, so that's the reason I told you carefully you have to follow the steps. Okay, so minus what I'm going to do is log of 36. I'm going to take this number 1 by 2 to the front, I mean to the power. Okay, so that it becomes 36 power half. Okay, now you can easily visualize this, right? So when you use the power rule, what happens? Again this 1 by 2 will go to the front, leaving the same previous step only. So that is what I'm doing in the opposite way. That's it, very simple. Okay, so now this became log of 36 power half minus next what do we have here? Here we have log of 1 by 30. So let us have that term also. Okay, log of 1 by 30 also we will have it as it is. Okay, so we'll have it as log of 1 by 30 itself, because this is simply in terms of log only, right? So we can have it as it is, no issues. Okay, yeah, fine. Yeah, coming to the next step, what we can do now is I can even simplify. I can try to simplify the terms, is it or not? So how I can simplify is I can write as log of this 2 square can be written as 4, right? So 4 plus log of 5 minus, now what about this term here? Just see here, see here carefully. Log of, we have 36 power half. So we know the power half. Okay, we know what we need to do when we have a half in the power. Okay, what we actually do there? 36 power half. What we need to do there actual thing is what is done there. Okay, maybe I can use a small step here. Okay, 36 power half. This simply means what? This simply means, it's very simple. It means root of 36. That's it. Very simple. Okay, square root of 36. What is 36 power half? Okay, so this is what is happening over here. So that means root 36. 36 power half is root 36, which is nothing but 6. I can write like this, right? So that means this becomes log of 6 minus, what about this one? This becomes log of 1 by 30. Simple, that's it. Okay, now if you see, all the terms are simplified, and also we are writing it as log. This is how we are writing it. Okay, yeah, fine. Yes, okay, I hope it is very much clear to you as of now. Now next what I'm going to do is I'm going to use again the first two laws of logarithm. Okay, what are the first two laws? The product rule, the product law, and the quotient law. Those two laws are what I'm going to use. Why I can use them is, it's going to be very simple. See here, I have plus and minus contained. Okay, I am just having the plus and minus signs in between the logarithmic values. So for that reason, I can very well use what? I can use the product rule and quotient rule. We can very well use them, right? So we can use them, and how we have to use them, that should also be very clear. Okay, so the plus terms should be multiplied and the minus terms should be coming to the denominator position. Okay, why? Because they are like fractions, right? When we have minus, we will have to divide it. When you have plus, we have to multiply it. That's how we have seen the rule, right? So let us use it carefully. So this will become what? Log of, let me try to do the entire thing in one single step itself. Okay, so you should carefully recall it, and then you should carefully follow it. Only then you will be able to understand it. Okay, so log of, what about this 4? This 4, we have plus 5, so I can multiply it with 5. Then I have minus log of 6 and minus log of 1 by 30. Now both are in minus only, right? So that means both the things I'll put it in the denominator itself. Okay, I hope you're able to follow this. Both the things I'm going to put it in the denominator itself. So if I put it in the denominator, I will have 6 into 1 by 30. Okay, be careful in understanding this step. I am simply using the first two laws of logarithm only, the standard laws. Okay, so when we have plus, what happens to the logarithmic values? They will be getting multiplied. When we have minus, they will be divided. Okay, so what happens? This value into this value divided by this value, again divided by this value. Okay, anyways both of them are going to be divided, right? So that's the reason I'm just taking it like divided like this. Okay, I'm just taking like this. Okay, yeah, fine. Now all we need to do is we need to simplify this given expression. So we try to simplify it. What happens is like I can first of all cut this 6 and 30. This is exactly how many times? This is going to be 5 times. So we will have 1 by 5 here. We have 1 by 5 here in the denominator position. Now 1 by 5, which is in the denominator, when it goes to the numerator position, it will go as what? 4 into 5 into 5. I hope this is also very clear to you. Okay, so 4 into 5, this 1 by 5 which is there in the denominator will go to the numerator as into 5. That's what I'm writing here. So now following this, what will happen? So log of, this will become log of 4 into 5 into 5. What is 4 into 5 into 5? It's exactly 100, right? Because 4 5s are is 20, 25s are is 100. That's it. Okay, so we have log of 100, and again it is common logarithm, right? This is common logarithm. So log of 100 to the base 10. This is how we are ending with, right? Okay, so what we can do here, we can just write this 100 as 10 square to the base 10. Now in turn I can now bring this 2 to the front. So it will become what? 2 log 10 to the base 10. I'm again using the power rule only. Okay, so 2 log 10 to the base 10. This 2 comes to the front. That's all. Now what happens is 2 into, what about this term? This is going to be as usual 1, right? Because this is common logarithm. Remember that. So log of 10 to the base 10, or simply log 10 will be 1 only. So 2 into 1, our answer will be finally 2. This is going to be the answer for our fourth subdivision of this question. So it seems to be a little critical for you to understand, but it is not at all going to be harder or difficult. You just have to follow the steps very carefully. You follow it, you can easily understand and then get the answer. All right, okay, yeah. Yeah, you can just go through it once again, okay, so that it will give you more clarity. Okay, fine. Yes, if you want, you can again rewind the video and then see. And I'm again using the same laws of logarithms only to solve the problem. Okay, maybe here at this step you may be having little confusion. This is not going to be a very complicated step at all. Just I just try to make everything in a single step. Okay, that may be the reason for you to have a little discomfort. Okay, I can even bring you a clarity by explaining it once again. So we will have this log 4 plus log 5. So 4 plus 5 minus this one is 6, minus this is 1 by 30. Okay, everything are in terms of log and log and log. So what happens when we have plus, they will be multiplied, and when we have minus terms, that will be divided. Okay, that 2 minus terms are there. That's the reason I've just made it divided entirely, and I made 6 into 1 by 30. 6 into 1 by 30. I made like that. Okay, so this is what is happening here, and once you simplify this, you will be getting this step, and you just log 100, and hereafter you will be able to understand. I hope this will be very clear to you, but this step alone you need to be very careful. Okay, fine. Yes, so this is going to be the solution, and answer for this question is going to be 2 is the answer. Okay, all right. Coming to the fifth subdivision. Okay, here fifth subdivision also, this seems to be even more critical. Okay, of course this is going to be a little harder question. Okay, so I'm not trying to make you feel panic, but anyways I'm just revealing it, okay, so that you will be prepared to answer this question. That's the reason. Okay, so yeah, coming here to this question, you have very big expressions here. We should really carefully work out this question and then get the answer. So kindly, I'm again insisting you to kindly carefully follow in solving this problem. Okay, all right. Yeah, you can even try this problem along with me. Fine. Okay, you can try along with me, because we have numerous in between calculations to be done also there, so that it will be easy if you work out also. Okay, not just listening, you also, if you try to work out this question along with me, you will have a better clarity, so that again, once again later, if you just open and see how the steps are worked out, you can have the clarity. Okay, you will have a better understanding. That's the reason. Yeah, coming back, here we have fifth question. Okay, fifth question, we have very big expression we have here, log 2 plus 16 log of 16 by 15 plus 12 log of 25 by 24 plus 7 log of 81 by 80. Okay, so such a big expression we have here. We need to simplify this and evaluate the answer. Okay, that's going to be the task which we need to do here for this question. So again, for this question also, we are going to employ the same technique what we followed here. Okay, yes, ready? We are going to use the same technique here. So what I'm going to do is, I'm going to write everything as log of some value. That's it. Okay, so the first term will be log 2. Let me write as log 2 itself. Very simple. Now next term is 16 log of 16 by 15. This is what we have, right? So 16 log 16 by 15. This is what we have. Now I can bring the 16 to the power position, so that it will become what? Log of, it will become log of 16 by 15 whole power 16. I hope you are able to understand this. Is this clear? Because like, you can use the power rule. Very simple. You are just again using the power rule only. This 16 goes to the power, so it becomes 16 by 15 whole power 16. That's it. Okay, plus continue. Here again I'm going to do the same thing. Okay, 12 log 25 by 24. This is what we have, right? So we can rewrite this as log of 25 by 24 whole power 12. I can rewrite like this. Then again plus log of, we can do this one like 81 by 80. Carefully see this, 81 by 80 whole power 7. Okay, so all the powers, the values which we have in the front, I have just taken to the power positions. That's all I am doing. I am just simply using the power rule. Okay, this 16 goes to this power, this 12 comes here to the power, this 7 comes here to the power. Okay, and when it comes as power, it will come for the entire fraction only. Okay, yes, so this power belongs to both the numerator and denominator. Okay, everywhere. Okay, so the powers, wherever the powers are there, it is for the both the numerator and denominator. Okay, it's for the whole fraction. That also we should understand. Okay, yeah, fine. Yeah, continuing here, we will have log 2. Then what we can do here is, now I can do this one like, okay, maybe I can directly use this step now. Okay, what I can do here is, since we have everything expressed in terms of log of plus log of plus log of plus log of, what we can do now? We can simply do a thing. What we can do here is, I can just directly use the first logarithmic rule. Which rule is that? It is the product rule, right? When we have plus log of value plus log of value plus log of value plus, what we can do? We can use the product rule. Okay, when we use the product rule, what will happen? This entire thing will become, this will become 2. Since we have plus 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 in between, what happens inside the logarithm? It will be getting multiplied, right? Okay, so they will be multiplied. So we will have log of 2 into this 16 by 15 whole power 16, right? Okay, so now I am again going to rewrite this as 16 power 16 by 15 power 16 into, now this one will become 25 power 12 by 24 power 12 into last one 81 power 7 by 80 power 7. This is what it becomes. I hope you are able to follow this step. So very simple thing only. So when we have log of the values which are getting added, when we use the product rule, what happens? We will have one log outside, log of all the other logarithmic values will be getting multiplied inside. This is what happens. This is what is product rule itself, right? The same thing is what here also we try to do, right? Here we have log 4 plus log 5 minus log 6 minus log 1 by 30. I took it as one log outside. Then what I did? Wherever multiplication came, I just used the multiplication. Sorry, wherever addition came, this plus sign indicates addition, right? So when these two terms or logarithmic values are added, I use the multiplication here, right? Okay, and when we add subtraction, what we did the division process. Okay, so addition we used to do multiplication. Okay, this is product rule, and whenever it is subtracted, we will be using the division. That is the quotient rule. But here there's no use of doing the division. Why? Because we have all addition only. Okay, when we have all additions, we can just do multiplication alone. Okay, that's what we are doing here. So now this will be equal to log of Now what we can do here, again another step we should be very carefully seeing here. So what we can do here is just carefully see the numbers here. So here is where the real action follows, okay, for this problem. Okay, we have very big complicated numbers, we need to transform these numbers. Okay, we need to transform the numbers. Look carefully what I'm going to do. Okay, so here only I'm telling, if you are going to miss the thing, you will be feeling very hard to understand this. Okay, so for a better understanding, I will just develop a new column here. Okay, for us to do some rough work, we will have this column. Okay, so now what I'm going to do is I'm going to transform these numbers into other forms. Okay, how I'm going to transform? I'm going to write the same numbers as powers of small numbers. That's it. Okay, so now we have 2 into, okay, so this 2 into, now see the first term here, what do we have? Here we have 16 power 16. Okay, let me write it. Okay, this 16 power 16 I'm going to rewrite. Okay, how I can rewrite? Basically, what is this 16? Just think of that 16 can be written as power of what number? You can write 16 as power of 4. Again, you can write as power of 2. That is also possible, right? So that means overall I can rewrite this 16 as power of 2. Just think of this 16 is 2 power what number? Think of until 16 can be written as 2 power what? It's going to be what? 2 power 4. Is it or not? Very simple. This 16 is nothing but 2 power 4 and once again whole power 16, because we have 16 itself raised to 16. Is it or not? So that means be careful. 16 power 16 I am going to rewrite it as, this 16 I am rewriting it as 2 power 4 and 2 power 4 whole power 16, right? Okay, now according to the exponents axiom, what happens? 2 power 4 the whole power 16, it will become what? It will become 2 power, this powers will be multiplied. Is it or not? The powers will be getting multiplied, so it will become 2 power 4 into 16. What is 4 into 16? What is 4 into 16? It's going to be 64. Is it or not? So that this will become 2 power 64. So now I am going to replace this 16 power 16 as 2 power 64. Okay, be careful. 2 power 64 into, I am going to do the same kind of process for all these numbers. Alright, okay, so be careful, be very conscious, okay, in doing the problem. Even if you are going to miss one number or one digit, you will have a wrong answer only. We'll end up with the wrong answer only. That's the reason. Okay, so be careful in doing this steps. Okay, now next we have 25 power 12. This also let's try to rewrite. Okay, 25 power 12. How can you rewrite this? Again, think of this 25 can be written as what? 25 can be written as 5 square. Is it or not? So if I think of a lesser number to write as a power, I can have 5 square. So 25 can be written as 5 square again raised to power 12. So now what happens again? So this will become 5 power 2 into 12. When we have power of power, we will multiply the powers. 2 into 12, which is 24. So we will have 5 power 24 here. Okay, yeah, multiplied by, next here we have 81 power 7. This is what we have, right? So 81 power 7 we have. Now again coming to this 81, how we can write this 81? Or 81 is going to be a power of which number? Okay, just think of, okay, 81 can be written as power of which number? 81 is basically 9 square. That is, we can write as 9 power. And again that 9 is nothing but 3's power, correct? So that means overall I can rewrite this 81 as 3 power some value. Is it or not? I can very well do that, right? So just think of this 81 can be written as what? 81 can be written as 3 power what number? Just think of and see. 3 power 1 is 3, 3 square is 9. Then 3 power 3 is 27. 3 power 4 will be 81. That's it, very simple. So this 81 can be replaced as 3 power 4, then a power 7. Okay, because we have 81 itself raised to power 7, right? That's why. Okay, so overall we are writing it as 3 power 4 power 7. So this in turn becomes 3 power 28. Because we can multiply the powers, right? 4 7s are 28. So now I am going to replace this as 3 power 28. Okay, I hope so far you are able to follow. Okay, everything is very clear to you. I am just writing all those numerator numbers as powers of smaller numbers. This is what this transformation is, what I am doing. Okay, yes, yeah, fine. Now next, coming to the denominators also we are going to do the same kind of process, but here bit we should be careful. Okay, why? Because see the numbers what we have in the denominators, here only we should be careful. Okay, so here we have 15 power 16. Okay, let's come to the denominator numbers. Okay, 15 power 16. Now what about this 15? This 15 can be written as what? Can you write 15 as a power of some other number? No, not possible, right? You can't have 15 to be power of some other number. You can't write 15 as 2 power something, 3 power something, or 4 power something. It is not possible, okay? So what we can do here, it's going to be very simple. We can decompose this 15. I can decompose it as what? I can decompose this as 3 into 5. That's it, okay? This 15 can be written as 3 into 5 the whole power 16. So now what will happen? This will become 3 power 16 into 5 power 16. Because I have 3 into 5, right? Both of them will have the power. So it becomes 3 power 16 into 5 power 16. Okay. Now I am going to replace this 15 power 16 as 3 power 16 into 5 power 16. Okay. So hope this is clear to you. Next, coming to this 24 power 12. Okay. This 24 power 12, this also I am going to write in the same way. Okay. Again, I am going to decompose this 24. How can you decompose the 24? 24 can be written as what? 24 can be written as, just try to write as, break it as numbers, smaller numbers, okay? So how can you break it? So 24 can be written as what? It can be written as 3 8s or 8 3s, right? Again, that 8 can be written as what? 2 cube, right? That is, this 24 I am writing as 2 cube into 3, okay? Again, the whole power 12, okay? This looks little complicated for you to understand, but we have a clear reason why we are doing all these things, okay? We have a reason. 24 power 12 can be written as, this 24 itself I am writing as 2 cube into 3, the whole power 12, okay? Again, bring the 12 inside, it becomes what? This becomes 2 power 3 12s are 36 into 3 power 12. Okay, simple, that's it. Okay, now this will overall become, this 24 power 12 will overall become 2 power 36 into 3 power 12. This is what it will become, multiplied by, next we have 80 power 7. That also I am going to write as 80 power 7. Also I am going to write as, try to decompose this 80. So how can you decompose this 80? 80 can be written as 16 5s are, okay? Why 16 5s are? Again, I can write that 16 as power of 2. That's the reason, okay? So 16 can be written as what? It can be written as 2 power 4, correct? Yes. So that means overall, I can rewrite this 80 itself as, be careful, 2 power 4 into 5, the whole power 7. Okay, be careful in understanding that. That's the reason I'm doing the calculations, the steps very slowly. Okay, so 80 can be written as 2 power 4 into 5, because this is 16 into 5. 16 5s will be 80. I'm decomposing with smaller numbers, small prime numbers. That's why. Okay, so 2 power 4 into 5, the whole power 7. So this will in turn become 2 power, this is 4 7s are 28 into, this is 5 power 7 itself. That's it. Okay, so now I can replace this as 2 power 28 into 5 power 7. That's it. Okay, so we have completed the chapter. Okay, so now we have decomposed all the numbers in the numerator and denominator position. Why we are doing this, all these things? Okay, why we need to purposely do all these things? You may have the doubt now. Why? Because now if you see the numerators and denominators, all of them are going to be in terms of powers of 2, 3 and 5 only. Is it or not? You can even check it and see. Just check it and see. Numerator also you have everything 2 powers, 5 powers, 3 powers. And denominator also we have 2 powers, 3 powers and 5 powers. That's it. So now it will be easy for us to simplify, right? This is the reason we decomposed and then wrote it as different powers. Okay, so that's the thing. Okay, so now we will continue. Log of, this will become log of. Now take the similar powers. Okay, this is like 2 power 1 into 2 power 64. Okay, so I think you can even leave it as it is. Okay, so 2 into 2 power 64. Okay, 2 power 64 into 5 power 24 into 3 power 28. We can have the numerator as it is, but now come to the denominator. Okay, we'll come to the denominator. We will see what are all the values we have here. Denominator start from powers of 2. So powers of 2, I have 2 power 36 into 2 power 28. So what is 2 power 36 into 2 power 28? So when we have exponents having the same basis but different powers, when we have multiplication, what happens to the powers? Powers will be getting added. Is it or not? So in that way it becomes 2 power. What will become? This is 36 plus this 28. Okay, be careful. This 36 and 28 you have to add it. Okay, because this is 2 power 36, this is 2 power 28. Don't confuse and add some other numbers. Okay, so same basis, 2 power, we have the same basis. Those two numbers we have to add it. Okay, so when we add it, what happens? 36 plus 28. 36 plus 28 will be 64, right? So we will have 2 power 64 multiplied by, next we will just treat the 3 powers. Okay, what about 3 powers we have here? 3 powers we have 3 power 16, 3 power 12. Okay, so when you add these two powers, 16 plus 28, this becomes 3 power 28. I hope it is clear, right? Because this 3 power 16, this 3 power 12. So 16 plus 12 is what is this 28. So 3 power 28. And same thing for 5 power also. Okay. So now 5 power. What about 5 powers? 5 powers, what do we have? Here we have 5 power 16 and here we have 5 power 7. So now what we will have? We will have 5 power 16 plus 7. That is going to be what? It's going to be 23. Alright, okay, I hope it is very clear to you. So now we have written all the numerator and denominator terms as 2's powers, 3's powers, 5's powers. That's it, okay. Now all we can do now is, I can simply cut what are all the terms I can see here, okay. So now I think I can cut this 2 power 64, 2 power 64, they both will be cancelled. And next I can cut this 3 power 28, 3 power 20, that is also cancelled. And now I will have 5 power 24, 5 power 23. What about 5 power 24 divided by 5 power 23? That's going to be what? There's going to be, we can minus the powers, right? Because 5 power 24 by 5 power 23, you can minus 24 minus 23. What happens to the power? It will just become 5 power 1. So this becomes 2 into 5 power 1. So that is in turn becomes 2 into 5, which is log 10. So all this entire big expression is shrinked and it just became log 10. Very simple, right? Because it is like 2 power 1 is 2 power 2. I am writing it as it is, no disturbance. But this 5 power 24 by 5 power 23 alone is becoming what? This becomes, powers are getting subtracted. Why? Because 24 in the numerator and 23 in the denominator. The powers will be minus, subtracted, right? Because we have same base which are raised to different powers. When it is divided, we have to do what? We will minus the powers. That's what we are doing. So 24 minus 23, that is what is this 1. So 5 power 1. So 2 into 5 power 1 is nothing but 10. So log 10 is what we have. And finally log 10 is as usual. This is going to be 1. Why? Because the same reason. This is a common logarithm. So log 10 to the base 10. It's always 1. So answer is 1 for the fifth question. Okay. So this question went little complicated, but still, now to get the clarity only, I just gave the expanded steps. Okay. So once you follow it, you will be easily able to understand it. That's the reason I just gave you all these things also. I hope you are able to understand this. Again, have a view. Yeah, let's move on to the next question. Let's go to question number 3 here. Here the question is, express each of the following as a single logarithm. That is, we have 3 subdivisions here and we have the expressions with logarithms with different terms, and also we have three terms in these questions, and we need to simplify them as expressing them in single logarithms. This is going to be the question, okay, and we need to do it for each of these 3 subdivision questions. Let's try to do that. Starting from the first subdivision, here we have 2 log 3 minus 1 by 2 log 16 plus log 12. This is what we have. So let's start from here. So as usual, let us try to use the power rule first, okay. So when I apply power rule here, this becomes log of, this is 3 square, that is this 2 will go to the power of 3. So this becomes log 3 square, that is log 3 power 2, okay. Yeah, minus, next what we will have here is, here this half will go to the power of 16. So this becomes log of 16 power half. Next we have log of 12. This is what it becomes, okay. Yeah. So this is equal to, next what we can do here is, this becomes log of, what about 3 square? 3 square is 9, right? So log 9 minus log of, what about this term, 16 power half? Hope you know what is 16 power half. 16 power half will be nothing but root of 16, which is nothing but 4. Is it or not? Because we know power half will be square root, okay. Power half, any number raised to half, power half will be equal to square root of that number, right? So root of 16, this is going to be 4. So that means log of 16 power half will now become log 4, then plus log of 12. This is what it becomes, okay. Now we can use the first 2 rules. Which are the first 2 rules? The product rule and quotient rule. These 2 rules we have to use, and then we can easily simplify and bring them as a single logarithm. That's it, okay. So now what we can do here is, I'm going to turn it as a single logarithm because we have all plus and minus only. So starting from the first term, here we have 9. Then we have minus log 4. That means this becomes what? Minus means we have to do what? We have to do division. So divided by 4. Then we have a plus log 12. So that means plus means we'll have to do multiplication. Okay, all right. So hope this is clear to you. So overall this becomes log of 9 into 12 by 4. Another way you can even look it as log 9 plus log 12. These two terms will be multiplied. Okay, 9 into 12 minus log 4. So that means this 4 should be divided. Okay, that comes to the denominator. Okay, so this is what it happens when we use the first two standard laws of logarithm. Okay, so now I can simplify this. How we can simplify? I can cut this 4 and 12. This is exactly 3 times. So now we can easily simplify this as log of 9 3s are 27. So log 27 is going to be the answer, and hence we are able to express this as a single logarithm. Okay, now using the same approach is what we are going to handle the other question also, other two questions also. Yeah, we'll go to now we'll move on to the second subdivision here. Here second subdivision we have 1 by 2 log 36 plus 2 log 8 minus log 1.5. This is what we have in the second subdivision. Here again we'll try to use the power rule. Okay, yeah, shall we start? So this becomes log of 1 by 2 will go to the power of 36. So this becomes 36 power 1 by 2 plus log of this 2 will go to the power of 8. So this becomes log of 8 power 2 or log 8 square minus log of this is going to be 1.5, right? So this 1.5 can be written as, maybe this 1.5 I am going to write it as 3 by 2, right? Because if we have fractions means it will be very better, right? That's why. Okay, so log of 3 by 2 I'm going to write like this. Now again what I can do here is log of, as usual we have 36 power half. How can I write 36 power half? 36 power half can be written as square root of 36. Okay, as usual, like how we did for the previous question, any number raised to power half will be square root of. So square root of 36 will be 6, right? So that means here we will have log 6 plus log, what about this one, 8 square? 8 square will be 64, right? So 64 minus this will be as it is, log 3 by 2. And again as usual what we can now do is we can just take it using the power rule, I mean like sorry, the first two rules, that is the product rule and quotient rule. Okay, we can use the first two rules here, we can apply it. So once we try to do it, what happens, wherever plus is linked you will have to do multiplication. So log 6 plus log 64, now here we have to do 6 into 64 minus log 3 by 2. So that means minus means we have to divide this term. So divide by 3 by 2. This is what we have to do. Hope you are able to understand this step carefully. So log of 6 into 64 by 3 by 2. This is what we have to do. So that means this will in turn become log of 6 into 64 into this by 2 comes to the numerator. This becomes into 2 divided by 3. Okay, hope you are clear with this step. So we have 3 by 2. That is, this fraction itself is containing a fraction, another fraction, the denominator. So this denominator of denominator, this 2 comes up, it becomes into 2. So we will have 6 into 64 into the 2 divided by denominator, we will simply have 3 alone. Okay, that's it. Okay, so this will be equal to log of, now all we need to do is we have to simplify this expression. Okay, so what I can do here is I can cut this 3 with this 6, so it's exactly 2 times. So now we will have log of 2 into 64 into 2. What is 2 into 64 into 2? It's going to be what? 2 into 64 is 128. So 128 into 2 will be 256. So log 256 is going to be the expression expressed in terms of a single logarithm. That's it. Okay, fine. Yeah, now coming to the third subdivision, here again we have a very similar question. This also we are going to handle in the same way. Okay, but this looks a bit complicated. Okay, like if you remember the previous questions, question number 2, how we solved the last subdivision, the same way, the same approach we are going to use for this question also. Okay, all right. Yeah, coming here you have 7 log 16 by 15. So that means this, when you use power rule, this becomes log of 16 by 15 power 7. Then plus log of this becomes 25 by 24 whole power 5. All right. Okay. Next, last one, plus log of this 3 goes there, 81 by 80 whole power 3. I hope it is very clear to you. All the power, all the front numbers, I am going to take it to the powers. That's it. Okay. Again, I am using the power rule. That's it. Very simple. The power rule of logarithm is what we are using here. So yeah, this is what we are ending up with. So now again continue. So what we will have now is log of. So since all the log values are added, what we can do in between? We can try to write as a single logarithm and we can multiply all these values, right? Whatever we have inside, we can multiply them, right? So when we try to multiply, what happens? This will become, this is 16 power 7 by 15 power 7. Is it or not? So what I'm going to write is, first I will collect all the numerators. So this becomes 16 power 7 into here 25 power 5 into this is 81 power 3. Now divided by, come to the denominator values. Okay, denominator values will be 15 power 7 into 24 power 5 into 80 power 3. I hope it is very clear to you. It is very clear to you. So now I'm going to use the same thing here. So what I'm going to do now is log of, I'm going to rewrite it using small numbers. Okay, small numbers powers. Okay, so in that way we will try to write as the 16 power 7. Okay, so if you remember, as I told, if you remember the previous second question, how we tried that, the same way, exact the same way I'm going to do this problem also. So let's try to do the question very carefully. Okay, yes, yeah, fine. So now what I am going to do here is, like this 16 power 7 I am going to rewrite. Okay, how can you rewrite it? Okay, 16 power 7, maybe I can take this space. Okay, I will take this space to simplify this. I think this will be enough for us to solve and get the answer. Okay, maybe I will just lift it a bit up. Okay, yeah, log of. So let us try to take this space to have the simplification. So start from 16 power 7. What about 16 power 7? This can be written as what? This can be written as 2 power 4 the whole power 7, like how we did there. Okay, how we did there, the same thing I'm going to do here. So 2 power 4 whole power 7. So this becomes, I'm going to substitute directly. Okay, 2 power 4 whole power 7 will simply become 2 power 28. Is it or not? So 2 power 28 into, what about 25 power 5? 25 power 5 can be written as 5 square power 5. Is it or not? Because this 25 I am replacing by 5 square. So 5 square power 5, this becomes 5 power 10. And then we will have into 81 power 3. What about this 81 power 3? This can be written as 3 power 4 whole power 3. Okay, so if you have a confusion, you can again revisit the second problem, the last subdivision, exact way how we solve that, the same thing I'm using here also. So 3 power 4 whole power 3, this is what it happens. So now this will become 3 power 12. So 3 power 12, it becomes whole divided by, again come to the denominator numbers, this is 15 power 7, right? So 15 power 7, I can decompose it as what? I can write as 3 into 5 whole power 7. So that means this becomes 3 power 7 into 5 power 7. I hope it is clear to you. Next we have 24 power 5. So 24 power 5 can be written as what? This 24 can be broken as what? This can be decomposed as what? That itself you have seen, right? You can write as 8 3s are, again that 8 can be written as 2 cube into 3 the whole power 5. So this will become 2 power 15 into, because 2 power 3 power 5. So 2 power 15 into 3 power 5. This becomes like this. And last one we have 80 cube, 80 power 3. This can be written as what? This can be written as 2 power 4 into 5, because 80, this is the way we have replaced in that question also. So if you again have a doubt, you can see that problem. So 80 power 3 is equal to 2 power 4 into 5 the whole power 3. So this becomes, I'll extend the denominator bar. So this becomes 2 power 12 into 5 power 3. I hope everything is clear to you. The substitutions are clear to you. So I'm just bringing the powers inside, and that's what I'm writing here. So 15 is 3 5s. So 3 power 7, 5 power 7. This is here. Now here we have 2 power 15, 3 power 5. This is here. And we have 2 power 12, 5 power 3. This is here. That's it. Okay, done. Yeah, okay. Next what I can do here is log of, I can just write this one as, so 2 power 28 into 3 power 12 into 5 power 10 divided by, now here also we'll try to do the same thing. Okay, here we have denominator as 2 powers, correct? The 2 powers, we will have 2 powers as 2 power 15 and 2 power 12. So what happens when we add the powers? It becomes 2 power 15 plus 12. So 15 plus 12 will be 27 into, next what do we have here? Next we have 3 power. Okay, 3 power how can be written? 3 power we will have, here we have a 3 power 7, here we have 3 power 5, and here we have, so that's it we have, right? Yeah, 3 power 7, 3 power 5, that's all we have. So 3 power 7 and 3 power 5. Now we can add those two powers. So 7 and 5, 7 plus 5 becomes 3 power 12, right? So 3 power 12 into, next come to the 5's power. Okay, 5's power we have 5 power 7 here, 5 power 3 here. So they both will become what? These become 5 power 7 into 5 power 3. That will become 5 power 7 plus 3, which is going to be 10. Okay, so 5 power 10. I hope it is clear to you. So take all the like powers, okay, like bases with the different powers. So what I did is 3 power 7 I'm sorry, I started with 2, right? 2 power 15 into 2 power 12. I added those two powers, 15 plus 12, that gave me 2 power 27. Next 3's power I took, 3 power 7, 3 power 5. Those two powers I added, that gave me 3 power 12. That is 7 plus 5, that gave me 3 power 12. And last 5's powers, if you take 5 power 7, 5 power 3, I added 7 plus 3, that gave me 5 power 10. Okay, this is going to be the step. That's it. Now we can very easily simplify, right? I can cut this 3 power 12, 3 power 12, 5 power 10, 5 power 10, and we have 2 power 28 by 2 power 27. So what about this? This is simply going to be what? 2 power 28 by 2 power 27. So what happens? So this will simply become 2 power 28 minus 27. The powers will be subtracted, right? So that means 2 power 28 by 2 power 27 will become simply 2 power 1. So that's nothing but 2 itself. That's it. Okay. So we have all the other powers got cancelled. We are left with only 2's power. That 2 power is 1. So log of 2 power 1, which is going to be log 2 itself. So that means the simplified form of this question is going to be log 2 is the answer for this third subdivision. I hope all the questions are clear to you. Again, have a look. Okay. So we are using the same power rule, product rule, and then quotient rule only to solve all these questions. Just have a look. Yeah, now we'll move on to the next question. Moving to question number 4. Here we have, if x is equal to 100 power a, y is equal to 10,000 to the power b, and z is equal to 10 to the power c, express log of 10 root y divided by x square z cube in terms of a, b and c. So we are given 3 expressions, that is for x, y and z. So each one we have one expression, where x is given in terms of a, y in terms of b and z in terms of c. Now the question is asking, this expression we need to express in terms of a, b and c. This is going to be the question. Okay, yes. So there's nothing to panic here. Let us see an approach how we can solve this question. Okay, yeah, fine. Now before that, let us start from what is given to us. Okay, so here we are given, here we have x is equal to 100 to the power a, right? Okay, yes. And also we have y is equal to, this is given to be 10,000 to the power b, and z is equal to, last one, yeah, 10 to the power c. This is what is given. Now if you see all these values, this 100, this 10,000, these values, we are very sure that we will be able to express them, each of them, in terms of powers of 10. Is it or not? Right? We can do that, right? So if we try to do that, what happens is, so here we will have this 100 can be written as 10 square, then to the power a. This way we can write. Is it or not? So x will be equal to 10 square to the power a, because we have a power a also, right? That's why. Okay. Yeah. All right. Now this in turn becomes what? What is 10 power 2 to the whole power a? What it will be? This will be simply 10 to the power 2a. Is it or not? That's it. Simple. Now we got x like this, 10 to the power 2a. Simple, right? Same way we'll try to express this y also. Okay. Now y we have 10,000 to the power b. Now this 10,000 can be written as what? 10 power 4. And again we have power b. So raised to the power b. So now this will become, y will now become 10 to the power 4b. Is it or not? Right? Yes. Because 10 power 4 the whole power b, the powers get multiplied. Okay. Because we can use the exponents axiom, right? So here when we try to use that, this becomes 10 power 4 the whole power b will become 10 power 4b. That's it. And last one here we have z is equal to 10 power c. Let us have this expression as it is. Let us not disturb it. Okay. Now overall what happened if you see? Just see here we have x also written in terms of 10 power. Y is also 10 power and z is also 10 power. This is going to be our objective. Okay. So if we have like this, it will be easy for us to get the answer. This is the thing. Okay. Now let us go to the question. Okay. See here the question, what we are asked to find is, find the value of log of, okay, let me just write it here. Okay. Log of 10 root y. Okay. 10 root y. Okay. I'll put a division because we have a division here. 10 square root of y. Okay, 10 into square root of, what about y here? We already have the value of y here, right? Y is given as what? Y we have already written as 10 to the power 4b. So just write it here. Square root of 10 power 4b. We can write like this, right? Sure, yes. I am just substituting the value of y here with what value we have expressed here. That's it. Okay. Yes, next, divided by x square into z cube. This is what we have in the denominator. Okay. Now in the place of x and z also we'll substitute these values. Ready? Yes. Yeah, we'll do that. So x square. So x square will become 10 power 2a the whole square. I hope you can understand this. Fine. Because x is already 10 power 2a. And we have x square. So what happens? 10 power 2a the whole square. This becomes like this. And last we have z cube. Okay, so z also will write like this. Okay, z is already 10 power c the whole power 3. This becomes like this. Fine. Okay, all right. Yeah. Now we will simplify this. We'll try to simplify this. So this becomes log of, what this becomes is log of. Now quickly we'll just simplify this. 10 into, now come here, we have square root of 10 power 4b. Is it or not? So this will become what? This I can rewrite as 10 power 4b the whole power half. I can very well do this, right? Yes? Okay. Now divided by, now you can bring this 2 inside and this 3 inside. Correct? If I try to do it, this becomes, this denominator part, this will become 10 power 2a into 2. This will become a 4a. And next here we have 10 power c power 3. This becomes 10 power 3c. Alright, okay. Because I'm using the axioms of exponents only. 2a into 2, that becomes 4a. And c into 3, that becomes this 3c. That's it, over. Next, continue this. Log of. So what I can do now is, this is like 10 power 1. Alright, okay, this is like 10 power 1. And here if you see, we have 10 power 4b to the power half. So this will become what? Again, I can multiply this half with this power. So this will become what? This will become 10 power, how much? 10 power, this becomes 10 power 4b into half. Is it honest? So 4b into half will become 2b. Simple, right? Yes. Divided by 10 power 4a to 10 power 3c. This will become like this. Now if you see, I have a log and all the values that I see here are in terms of powers of 10. Very simple. Okay, yes. Now overall what I can do here is log of, I can do what here I can do here is, I can put log of, just write 110. Just write 110, and whatever we have in the powers in the numerator, what we can do? This is like they are getting multiplied. Is it or not? They are getting multiplied, right? So that means what I can do here is 1 plus 2b. I can do like this, right? Because a power m into a power n will become what? A power m plus n. That's what we are doing here. So this is like 10 power 1. This is 10 power 2b. When they are multiplied, this becomes what? This becomes 1 plus 2b. It becomes like this. Okay. And the same way, with the same hand, what we will try to do is, see here we have divided by 10 power 4a and 10 power 3c. So now what will those powers become? They will simply become minus, because they are like a power m divided by a power n. So when we have a division with same powers, what happens to the powers? So when same numbers are raised to different powers, what happens to the powers when it is divided? It will become a minus, right? So that means it will become minus 4a minus 3c. I hope you can understand this. Clear? Okay, all right. Yes, fine. Let me continue it here. So now this will become log of. So here we have 10 to the power. Let me write it in a proper order. Okay, like first I'll write the constant 1. Then I will write the a term. Okay, a term will be minus 4a, then plus 2b minus 3c. Yes, now it will be clear to you. Okay, the same things. Whatever I have here, I'm just writing it in a proper order. That's it. Okay, yeah, fine. Now log's property, what happens? We can use the power rule. Is it or not? So when I use the power rule, the power term what I have here will come to the front. Is it or not? So when it comes to the front, it will become 1 minus 4a plus 2b minus 3c times of log 10. This becomes like this. Is it or not? Just I'm bringing the power to the front. That's all, right? Because power rule says what? Log of a to the power n will become what? N into log a. You can just bring that power n to the front of the log. That's what I'm doing here. Okay, yes, done. Now finally 1 minus 4a plus 2b minus 3c. This entire thing will be multiplied by what? What do we have there? We have log 10. What is log 10? Log 10 is simply 1. Why? Because the same reason we are seeing in the previous problem also, from the previous problems also. What we are doing here? Log 10. What is log 10? Log 10 means it's simply the common logarithm. Log 10 to the base 10. It's going to be 1. That's it, right? So this becomes 1. So our final answer will be 1 minus 4a plus 2b minus 3c. This is going to be the answer. So finally we have expressed this given expression, what we have in the question, in terms of a, b and c. And what is our expression? 1 minus 4a plus 2b, 1 minus 4a plus 2b minus 3c. This is going to be the expression, okay? Yeah, fine. So hence this is going to be the answer. Have a look once again, have a glance, then you will be able to understand. Fine, okay? Next we'll move on to the question number 5. Question number 5 we have, if a is equal to log 2 by 3, b is equal to log 3 by 5 and c is equal to 2 log of square root of 5 by 2. The square root is for the whole of 5 by 2, okay? Then find the values of, we have two subdivisions. We need to find the values of these two subdivisions, the expressions given. So coming to the first subdivision, we have a plus b plus c. Find the value of a plus b plus c, right? Okay. So this is equal to, we need to find the addition of a plus b plus c, and also what? We have the values of a, b and c given in the question itself, right? Okay. We will just simply substitute the values. That's it. Okay. Let's try to substitute. So a will be what? A will be log of 2 by 3 plus, what about b? B will be log of 3 by 5 and c is nothing but 2 into log of square root of 5 by 2. Okay. Square root of the whole square root of 5 by 2. This is what we have. So continue this. So log of, this is equal to log of 2 by 3 plus log of 3 by 5 plus, now what about this one? Here this third expression we have 2 log of square root of 5 by 2. Now what happens is, it's a very simple thing, right? We can use the power rule. I can just bring this 2 to this power of this logarithmic term. Now if I do that, what happens? So we will have log of 5 by 2. We already have a square root and along with that we will have a whole square. Try to understand the step very properly, okay? We are just using the power rule, that's it, okay? So the 2 what we had here, it just simply goes to the power of this value, okay? So what happens? Already we had square root of 5 by 2, that becomes a whole square, that's it, simple, okay? Now continue. So we have log of 2 by 3 plus log of 3 by 5 plus, now what about this expression, log of, what about this one? This will simply become what? Square root of 5 by 2 the whole square. So it's very simple, the square root and the square, they both will be cancelled. So we will simply have 5 by 2. This is all we will have here. So now we are with this expression, alright, okay? So now log of, now what happens here? We have log of this value plus log of this plus log of this. So when we have addition of logarithms, what we can do? We can clearly use which rule? The first rule, right? Yes. We can use the product rule, right? So when you use the product rule, what happens? So this will simply becomes log of 2 by 3 into 3 by 5 into 5 by 2. This is what it becomes. I hope you are able to understand this. So I'm just using the product rule, right? So if you use the product rule, we will have one log and the entire thing, it will become a product, okay? So this is what we will have. I hope hereafter it's going to be very easy. We can easily simplify this, right? So we can cut this 3 and 3, this 5 and 5 and this 2 and 2. So we will be left with simply log of 1. So that means the answer is going to be what? Log 1 to any base, it's going to be what? It is always 0. So that means the answer for our first subdivision is going to be 0 is the answer, okay? And now coming to the second subdivision, what is the value of 5 to the power a plus b plus c? And that's going to be very simple, right? So this is equal to 5 to the power. We already found the value of a plus b plus c, that is ready available from the first subdivision itself. So we have it to be 0, right? Just take that 0 here. So it simply becomes 5 power 0. And we know that any non-zero number raised to the power 0 is always 1, right? The answer is going to be 1, right? So yeah, so 5 power 0 is going to be 1. 1 is going to be the answer. And yes, these are going to be the answers for the two subdivisions of our question number 5. Moving to the next question. Coming to question number 6, here we have given 3 times of log 5 minus log 3 minus of log 5 minus 2 log 6 is equal to, right hand side we have 2 minus log n. Then here we need to solve and find the value of n. This is the question, okay? Yes. So that is, we have an equation which is full of logarithm and there's only one unknown. This n is the only unknown and we need to solve this equation and we have to find the value of n. This is going to be the question, okay? So let's try to carefully solve this question step by step, alright, okay? And as usual, we are just going to use the properties of logarithm. That's it. Okay. Yeah. Starting from the left hand side, here we have 3 times of, okay, so 3 times of, we have log 5 minus log 3. This is what is given here, right? So that means from here itself we can use the properties, okay, start using the properties. So what is log of A minus log of B? How can we write? So this is nothing but here we can use the quotient law, is it or not? So when we use quotient law, we have log of 5 by 3. I hope you can understand this, because quotient law says what? Log of the first value minus log of the second value will be equal to log of, we have to divide it, right? So that is why it is named as quotient law or the second law, okay? Yes. So according to the second law, the quotient law, we will have 3 times of log of 5 by 3. I am just placing this 3 outside as of now, okay? Yeah, coming minus, continue, okay, we'll continue now. Now coming here, here we have another bracket. So here we have log 5 minus 2 log 6. This is what we have, is it or not? Yeah, okay. We'll take a chance now. So log of 5 minus, I'm not going to just directly use any log here. I'm just going to use this log 5. I'm just writing this log 5 as it is, minus. Now come here, here we have what? We have 2 log 6. Now what happens to this 2 log 6? Here of course we can use the power rule, right? So when we use power rule, what happens? This 2 goes to the power of 6. So it becomes what? 6 square. It becomes like 6 square, okay, is equal to 2 minus log n. This is what it becomes. Fine, okay, all right. Yes, everything is clear. Now continue, okay, we'll continue now. Now what happens is, I can now do something, okay. What I can do here is, again I can use power rule here, okay. So when I try to use power rule, this 3 will go to the power of this 5 by 3, right, okay. So what happens now? So this will become log of 5 by 3 the whole cube. I hope this step you are able to understand it. So 3 log 5 by 3 is now becoming this power, I mean this 3 what we have in the front of logarithm goes to the power of this 5 by 3, okay. Remember, when you take it to the power, you have to take it to the entire value, okay. Not only for this 5 or not only for this 3, it becomes the power of this entire 5 by 3, okay. That we have to properly understand. Okay, continue. Minus, coming here, what we have here? Here we have log of 5 minus, now what about this one? Log of 6 square. Now I can write this as log 36 because 6 square is 36, right? That's why. Is equal to 2 minus log n. And I'm not disturbing the right hand side as of now. Let it be as it is. Yeah, coming again. Here we have log of. Now what about this expression? 5 by 3 the whole cube. This will be nothing but 5 cube divided by 3 cube. Is it or not? Yes. I can just distribute the power to both numerator and denominator. If I do that, what happens? 5 cube will be what? 125 divided by, here denominator we have 3 cube, that's nothing but 27. Yes, clear? Okay. Minus, now again if you see, here we can do what? We can use the quotient rule, like how we used here, correct? Log A minus log B, how we used here, here we wrote like this. The same way, now we can use the quotient rule here. Yes, shall we do that? If I try to use quotient rule, what happens is log of, this will become log of, now I have 5 and 36, right? So what happens is 5 by 36, this becomes 5 by 36. Clear? Okay, yeah, is equal to 2 minus log n. So far it is going well? Yes. Yeah, continue now. Now again log of, now what happens if you see, here again you have our expression what we have in the left hand side, we have it in the form log of some A minus log of some B. That means again we can use quotient rule, correct? Yes, that is log of this value minus log of this value. So I can do what? I can again use quotient rule. So how we can use it? So this will become log of 125 by 27 divided by, okay, divided by, I am using this division symbol itself, divided by 5 by 36. Is it or not? Yes, because this fraction is divided by this fraction. That's how it becomes. Is equal to 2 minus log n. Yes, fine. Everything is okay. Now let us do some adjustment here. Log of, okay, left hand side we have log of. Now what about this expression? Here we have 125 by 27 divided by 5 by 36. Now in order to simplify this, what we can do here is, I will change this division into multiplication. Then what we will do for the fraction, we will just take the reciprocal of that. So this will become 36 by 5. All right, okay. So is equal to 2 minus log n. This is what it becomes, right? It's a basic property, right? So whenever we have two fractions, when one of them is divided by the other, what we have to do? We have to simply take the division symbol as multiplication, and we can just swap the numerator and denominator. That is, we are taking the reciprocal. That's it. Okay, yes. Now coming back here, we can do some simplification process. Is it or not? So I can just cut this 5 and this 125. This is exactly 25 times. So yeah, 25 right here. And also we can cut this 27 and this 36. Yes, we can cut this 27 and 36, right? So both of them are divisible by 9 tables, right? So this is 9 3s are 27. And here this 36 is 9 4s are 36. Correct? Okay, done. Yes. Now I think we'll go to the right hand side. Since we have no space, we'll just continue the steps here. Okay, yeah, fine. I think that space is enough for us to get the answer. Yeah, continuing there. Now just continue it. Okay, so log of, what do we have now? Log of. See here, what do we have now? 25 into 4 divided by denominator, we only have 3. Okay, remember that. So that means we have 25 into 4. What is 25 into 4? That's going to be 100. So 100 divided by, here we have 3. So log of 100 by 3 is equal to, now come to the right hand side. Right hand side we have 2 minus log n. Now here is where we should be very careful. Yes, okay. Now see the right hand side, we have 2 minus log n. So what here we can do is, I am going to write this 2 also in terms of logarithm. How can that be written? Just imagine, okay, this 2 is here. Let's try to write or express the 2 itself as a logarithm. And before that, you look at all these logarithmic expressions. How are they present? They are all simply logs. That means they are all common logarithms, or otherwise they are all with base 10. Is it or not? So that means, how can I rewrite this 2? It's going to be very simple. Okay, so I'll take this space. Okay, so how can I write this 2? 2 is equal to log of what number we can write? It's going to be very easy. Since we are using common logarithm, log of what value will become 2? If you think it's going to be very easy. How we can write it? I can write this 2 as log of 10 square. Log of 10 square. Is it or not? I will show you how. It's very easy for you to understand, right? Why? Because just try to use power rule. What happens? This 2 goes to the front. This 2 will go to the front. Is it or not? So it becomes 2 is equal to 2 into log 10. This is how it becomes, right? This is how it becomes, right? So we already know log 10 is equal to 1. So that means 2 is equal to 2 into 1. That's it. Very simple. Okay. So this will now make you, or this will, I think this will satisfy, okay, your doubt. 2 is equal to, if I want to write this 2 as log of some value, how can I write it? 2 is equal to log of 10 square. I can write like this. Okay. So that means log of 10 square. What is 10 square? 10 square is again 100. So that means I can very well rewrite this 2 as log of 100. So I'm going to replace this 2. I'm going to write as log of 100 minus log of n. This way I'm going to write. Okay, clear? Yes, done. Continue with log of 100 by 3 is equal to, now what about the right hand side? Right hand side, again we got a form log a minus log b. That means here I can do log of a by b, that is 100 by n. I can do this. I can very well do this, right? So finally we got what? Log of 100 by 3 is equal to log of 100 by n. Now when you just cut the logs on both the sides, or in other words, if you take anti-logarithm on both sides, okay, so what happens? They both will be cancelled. So now we are left with 100 by 3 is equal to 100 by n, and that means n is equal to 3. Simple, right? Why? Because you can directly compare. Since we have two fractions equated and the numerators are same, what about denominators? Denominators will be same. Okay, so n is equal to 3. That's it. We solve for n, we got the value to be 3. Yes, I think this is making you understand the solution. The thing is clear to you, I hope. So just have a look as usual. So we're just using repeated the same rules only. Okay, the logarithmic rules only we are simply using. We are using the quotient rule and power rule. Repeated use is what is giving. And here we are doing a small change. Since all these values are given in terms of logarithm, this 2 alone is there simply as a number. This 2 also we are rewriting as a logarithm and then solving. It is letting us to get the answer very easily. Fine, okay. So anyways, we got the answer. N is equal to 3 is going to be the answer for this question number 6. Yes, let's move on to the next question. Here we have question number 7. Given log of y to the base 10 plus 2 times of log of x to the base 10 is equal to 2, then express y in terms of x. So we have a relation between y and x that is given in terms of logarithmic, but we need to get the expression or we need to express y in terms of x without that logarithms. Okay, that's what the question is expecting us to do. Let's try to do that from what is given to us. Okay, yes. So let us see here what is given. So here we have this expression, log of y to the base 10 plus 2 log of x to the base 10 is equal to 2. This is what is given. Okay, and since here we have the log to the base 10, it simply means it is a common logarithm. All right, okay, yeah, fine. Anyways, let us start from what is given to us. What I'm going to do is I'm going to take this step, I'm going to take the next step itself, I'm going to start simplify. Okay, yeah, log of y to the base 10 plus, here what we can do, we have 2 log of x to the base 10. That means clearly we can use power rule. I will just take this 2 to the power of x. So what happens? We will have log of x to the base 10, but this is not only x, this is going to be x square, right? Yes. Why? Because I can just take this 2 to the power 2x. Okay, so this becomes x square. This is equal to 2. This is what it will be. Yeah, now continue. We will have what? Log y to the base 10 plus log x square to the base 10 is equal to 2. This is what we have, right? Okay. And next what I can do here is, now we will use the product rule. That's it. Okay, because we have the form of log a plus log b. Is it or not? So that means we will use the product rule. So what happens? Log of y into x square. Yes, we have log of y into x square to the base 10 is equal to 2. This is what we have. Is it or not? So we got log of yx square to the base 10 is equal to 2, because these two will be getting multiplied, correct? We will have only one logarithm, and when we use the product rule, what happens? Log of first value plus log of the second value, and since we have the same basis, what happens? Log of the same base of what value? It will become the product of that. Okay, so that's what y into x square. That's what I am simply writing it to be yx square. All right, okay. Now this is in terms of logarithm, right? This is in terms of logarithm. Now we have to write it in an exponential form. Let's try to write an exponential form. So what happens? If you try to write this expression in terms of an exponential form, so what happens? This we are seeing from the starting, right? So we know how to convert a logarithmic form to exponential or exponential to logarithm. We have already seen that, right? So let's try to bring this logarithmic form to exponential form. So what happens is, like, we will have it to be like 10 power 2 is equal to yx square. This is what it becomes. Is it or not? Or in other ways, I can write as yx square is equal to 100. This is what it becomes. And finally, we are asked to find x plus y in terms of x. This is what we are asked to find. So that means we have to find y is equal to what? This is going to be the question. So we have yx square is equal to 100. So y is equal to, we will have it to be 100 by x square, right? Okay. That's it. So we got y in terms of x. So y, if we express in terms of x, what is the answer? 100 by x square. That's going to be the answer. Okay. Yes, it's going to be a very simple solution only. I hope you are able to understand. Very simple properties, very simple solution. Just some 3 or 4 steps, we are able to get the answer. Okay. Yeah, have a look. Now we'll move on to the next question. Next we have question number 8 with us. Here our question is, if a square is equal to log x to the base 10 and b cube is equal to log y to the base 10 and a square by 2 minus b cube by 3 is equal to log z to the base 10, then we have to do something. What we are asked to do here is express the z in terms of x and y. This is going to be the question. Okay, again, it's not going to be very complicated, very tough question. It's going to be very easy only. Yes, okay, yeah. So we are given 3 expressions actually to say. One is a in terms of x and the other one is b in terms of y, and the third relation we have a and b, right? Okay, so this z, log z, okay, this z is given in terms of log, and this expression, it is given in terms of a and b. This is how it is related. Now let's do a thing. Let us start from here. Okay, this expression. Okay, we'll start from this expression. I'm going to place an arrow mark notating that I'm going to use this. I'm going to start from here. Okay, Just carefully see what is given to us. We have a square by 2 minus b cube by 3 is equal to log z to the base 10, right? Okay, fine. And also here we have a square and here we have b cube. Now if you carefully look at those two expressions, we have a square and b cube are already given in terms of x and y respectively. Is it or not? Yes, fine. So that means we are going to substitute these relations here in this equation. Fine. Okay, shall we do that? Yes, I hope you are able to understand. The idea is clear to you. Let me repeat what I am going to do. Here we have a square and here we have b cube. We are going to substitute these expressions here. That's it. This is what we are going to do here, right? Okay, fine. Yes. Now we have here a square by 2, correct? So here in the place of a square, let us substitute this expression. Okay, we have a square is equal to log x to the base 10, right? So let us just substitute it here. So what happens? We will have log x to the base 10 divided by 2. Is it clear? Log x to the base 10 divided by 2 minus, next what do we have? Here we have b cube. And b cube, what expression we have here? Here we have log y to the base 10. So log y to the base 10 divided by 3 is equal to, this is what is equal to, see the right hand side. Right hand side we have log z to the base 10. That's it. This is all we are doing here. Simple. Okay, right? Yeah. Okay. Next, see here we have log x to the base 10 whole divided by 2. This what is this whole divided by 2? This is like half. Is it or not? So we can very well write this as half of log of x to the base 10 minus, similarly here also, what about this by 3? This is like 1 by 3. So I am writing 1 by 3 log of y to the base 10 is what is equal to log z to the base 10. Yes, is it clear? Okay, yes. Next, what we can do, as usual, since we have the values, log values, we have some constants fit in front of them, we can very well use what rule? We can very well use the power rule now. Is it or not? So we can use the power rule. So once we use power rule, what happens? This will become log to the base 10. Here what happens? It becomes log x power half minus, here also what happens? Log to the base 10. Here what happens? Y power 1 by 3. Do you understand this? I am just bringing this half to the power of x and just bringing this 1 by 3 to the power of y. That's it. So this 1 by 2 goes here, x power 1 by 2. This 1 by 3 goes here, y power 1 by 3 is equal to log z to the base 10. Okay, cool, done. Next, what we can do? Now we have what? We have these expressions, right? So if you want, we can even simplify this. So first of all, what I am going to do is I am going to rewrite them. Okay, I am going to rewrite them as log. Okay, log. Now what I am going to do is I am going to rewrite these values as this x power half. How can you rewrite this? What about x power half? Any number raised to the power half, it's nothing but what? It's going to be square root of that value. So root of x. Okay, so log root of x to the base 10 minus, here what do we have? Log of, here we have y power 1 by 3 we have, correct? So that can be written as what? Power 1 by 3 can be written as cube root of y to the base 10 is what is equal to log z to the base 10. This way we can write. Okay, yes. Yeah, continuing on the right hand side. Okay, we'll just continue it on the right hand side. So what next we can do here is we can very well use now the quotient rule. Because we have what expression? We have log of one value minus log of the other value. So once we have two log values are getting subtracted, we can very well use quotient rule. Is it or not? We can use the quotient law, the second law. So once we use the quotient law, what happens? Log of, we will have log of. Now what do we have here? Here we have root x and here we have cube root of y. So what happens? They both will be getting divided. I mean this value, that is square root of x divided by, here we have cube root of y. This becomes like this to the base 10. This is what is equal to, come to the right hand side. Here we have what? Log z to the base 10. That's it. Okay, clear? Fine. That's it. Okay. Now what do we have finally? We got like this. Log root x by cube root of y to the base 10 is equal to log z to the base 10. Now if you clearly notice, what is there on both the sides? We have both these sides having logs with the same base, and that means I can just cut them. Is it or not? We can cut it. So what we will be ending up with? We will just have this z is equal to, see here we have root x divided by cube root of y. This is all we are going to have. Simple, right? Is it okay? So that means finally we did what is asked for us to do in the question, right? See here, express z in terms of x and y. That is what we are asked to do in the question. Express z in terms of x and y, and that's what we have done here. Z in terms of x and y. So what is z now? Z is equal to square root of x divided by cube root of y. That's it. Simple. Okay, done. So this is going to be the answer for our question number 8, and I hope you're able to understand this also. Fine. We'll move on to the next question. Next we have question number 9, another interesting question. Given log x is equal to m plus n, log y is equal to m minus n, we have to express, here we have an expression, okay, log of 10x by y square, we have to express this expression in terms of what? In terms of m and n. This is going to be the question, okay. So something interesting we have here, and that too, it is again going to be an easy question only, right? Okay, yes. So here you see log x, we have this log of x given in terms of m and n, and also log of y also given in terms of m and n, right? Okay, so we have to express this expression. What expression? We have log of 10x by y square. This is what we have to express. All right, okay, fine, yes. So now what I'm going to do is, since we have to express this one, I'm going to start from this expression itself. Okay, yes. Let us start from this expression itself. What is that expression? Let us just rewrite it here. Fine. Okay. So we have what? Log of 10x by y square. This is what we have, right? So let us start from here. This is equal to, now what I'm going to do is, I'm going to rewrite this as, I'm going to use the quotient rule, right? Okay. Let us use the quotient rule. That is, here we have what? We have log of a by b. We have such a form. Is it or not? We have form what? Log of a by b. So that means what we can do here is, I can rewrite this as what? Log of a minus log of b. I can very well write like this, right? Yes, is it or not? We can very well write like this. No issues at all. So log of a by b can be written like this. Log a minus log b. This is what I'm using. I'm just simply writing using the quotient rule. That's it. Okay. Yes. Fine. Now once again, if you see here, see this expression. Here what do we have? Log of, we have 10x. Now this is like a product. Is it or not? This is a product. This is like 10 into x. Now what I can do here is, I can use the product rule now. I can use the first law, the product law. So once I use this, what happens here is, this log of 10x, this can be written as what? This can be written as log of 10 plus log of x. I hope you can understand this. Fine. Okay. And now what I can do here is, I can just put this one, okay, minus. So what you can do here is, like, now log y square you have. So here if you see this term, this can be written as what? I can use the power rule, and I can just write this as, this 2 I can bring it to the front. So this will become 2 log of y. Clear, isn't it? Right? Is this clear? So just a very simple thing, okay. We are just using, first time we are using the quotient rule, and next for this expression we are using the product rule, and this one we are using the power rule, okay. And if you are able to recognize everything at the first moment itself, you can directly come to this step. There's nothing wrong at all. Okay, fine. So directly you can write it. Okay, you can just split it here by a product or by a quotient. I mean, like, you can just write as a minus. Here this you can write as a plus, and you can use the power rule. You can write like this. Okay, there's no issues. But since if I just give it like step by step, you will get a clarity. I'm just doing like this. Fine. Okay, all right. Yeah. Anyways, we'll continue now. So now continuing, we have what? We have log 10. What is log 10? Since all these logs are given in terms of simply log, they are all going to be common logarithm, and the base is going to be 10. In that case, log 10 is simply going to be 1. All right. Yes. Okay. Plus, now come here, we have what? Log x. Is it or not? So log x is given. We already have the question. Log x is given as what? Log x is given to be m plus n, right? So now here, in this place of log x, I can substitute this m plus n. So m plus n minus, now come here, we have what? 2 into log y. We have 2 log y, right? So 2 into log y. Now see the question again. Here in this question we have log y given in terms of m and n, and how it is expressed? Log y is equal to m minus n. That's how it is given, right? Now I can substitute this expression here. So what happens? 2 into this log y I will now write as m minus n. Fine. Okay. Is this clear? Yes. Okay. So simple thing, log 10 I'm writing as 1, and log x I am replacing with m plus n, and 2 minus 2 into log y I am replacing it as m minus n. That's it. Okay. Now all we need to do is just simplify this expression. So if you simplify this, what happens? 1 plus m plus n minus, so just bring this 2 inside. So what happens? This becomes minus 2m, because minus 2 into m will become minus 2m, and minus 2 into minus n will become plus 2n. Is the point clear? Yes? Yeah. Okay. Continue. Yes, we'll continue. 1 plus, now what happens is, sorry, 1, now what happens is, I'm just clearing this, 1, see here, if I see the m terms, what I have here? I have plus m minus 2m. I have plus m minus 2m. This is like plus 1m minus 2m. So what happens when you simplify this? These two if you put together, what happens? This will become a minus 1m, so minus m. This becomes minus m, and here we can connect these two terms because these two are n terms, right? So plus 1n plus 2n, that becomes plus 3n. Is the point clear? Yes, I hope you are able to understand this. So yes, done. That's it. Finally we got the answer as 1 minus m plus 3n. This is going to be the answer for this question. So finally we have successfully expressed this expression in terms of what? In terms of m and n, as it is asked in the question. All right. Okay, so these are going to be the expressions. Okay, yes, so fine. Yeah, that's it. We are able to get the answer for the question. So just see the steps. Now we'll move on to the next question. Next is question number 10 with us. Here we have to solve for x. We have got 3 subdivisions, and in each of this we have logarithmic equations, and we have the unknowns as x. We have to solve and then get the value of x. This is what we are asked to do. Start from the first subdivision. We have log x plus log 5 is equal to 2 log 3. A very simple equation. So let's start from here. Okay, the first subdivision. So we have to start like what? Log x plus log 5. This is what we write. So we have it like log of. Now what we can do? We can easily use the product rule, right? So once we use product rule, what happens? Log of. Here we have x and here we have 5. So what happens now? We will have it to be very simply x into 5. That's it, right? Because we can write as 1 log and we can write as x into 5, which is going to be 5x. So log of 5x is equal to, come to the right hand side, here we have what? 2 log 3. This is what we have here, correct? We have 2 log 3. So that means this, if we use power rule, what happens here? So this will become log of, this becomes, this 2 goes to the power of 3. So this becomes log of 3 square. This is what it becomes. So now we have both these expressions given in terms of what? Log of some value and log of some value, and both of them are going to be of same base only. So in that case we can cancel these logs. So we will be simply left with 5x is equal to, here we have 3 square. What is 3 square? 3 square is going to be 9. So 5x is equal to 9. So that means x is equal to 9 by 5 is going to be the answer for our first subdivision. Simple, right? Very good. Okay, now come to the second subdivision. So here we have log x to the base 3 minus log 2 to the base 3 is equal to 1. This is what we have, right? So how can we handle this? Here we have log x base 3 minus log 2 to the base 3. So since we have minus, here we can use the quotient rule. Is it or not? So once we use quotient rule, what happens? Log of, it becomes log of, here we have x, here we have 2. So this will become x by 2 with the same base 3. Log of x by 2 to the base 3 is equal to, what about right hand side? Right hand side we will have 1. So now we got what? Log of x by 2 to the base 3 is equal to 1. This is a logarithmic form. If we have to write this as an exponential form, then what we have to do? We can write as 3 power 1. So 3 power 1 is equal to x by 2. This way we can write. Is it or not? Or otherwise we can write x by 2 is equal to, this is 3 power 1, which is 3. And now if we solve for x, we will be getting what? X is equal to, this 2 goes there. So it becomes 3 into 2. So 3 2s are 6. So x is equal to 6 is going to be the answer for our second subdivision. Now last one, coming to the third subdivision, here we have a big expression here we have. So what we can do here is we have log 8 by log 2 into log 3 by log root 3 is equal to 2 log x. So this is what we have here, right? So how we can handle this one is, yeah, we'll go further. Okay, so what we can do here is start from this log 8 and here we have log 2. So we have log 8 here, right? So let's try to write this log 8, this 8 as a power of this 2. We can do that, right? So we'll try to write this 8 as power of 2. So what happens? So if we try to do that, we will have log of 2 2 to the power 3. Is it or not? We will have this 8 can be written as 2 power 3 by log 2. This way we can write. We can very well write this way. Okay. Multiplied by. Now come here. Here we have what? Log 3. Okay. Now I will have that log 3 as it is. We will have this log 3 as it is. Or even we can even do a small trick. Okay. See here how we wrote this 8 in terms of this 2, right? Okay, this 8 we wrote as a power of 2. Same way, we will write this 3 as a power of root 3. Shall we try doing that? Let me explain you clearly. See, here we have 2 in the base denominator, and here we had what? Here we had 8 here, correct? So this 8, how we wrote? 2 cube, we wrote like that. Same way, here this 3 also we will write like what? We will write it as log 3, we will write as log 3 the whole square. Root 3 the whole square. We can do like that, right? We can very well write like this, right? Why? Because we have root 3 here. That's why. Okay. Now log root 3 is equal to. Now come to the right hand side. Right hand side, what do we have? We have 2 log x. Now we will use the power rule here. So if we use power rule, what happens? We will have log x square. This is what we will have in the right hand side. Okay. All right. Yeah. Continuing. Now I will again use power rule here. If we use power rule, this 3 comes to the front. If it comes to the front, it becomes 3 log 2 by log 2. And same way multiplied by, here also I can bring this 2 to the front. If I bring the 2 to the front, it becomes 2 log root 3 by log 3, log root 3, I'm sorry, log root 3 is equal to, what about right hand side? Right hand side we have log x square. This is what we have. Fine, alright, okay. Now what I can do very well, I can just cut log 2 with log 2, log root 3 with log root 3. So we will have simply log x square. I will just bring this log x square here. This is equal to, now what happens to the this side, the other side? This becomes 3 into 2, which is going to be what? 3 into 2 is going to be 6. Okay, yes, 3 2s is going to be 6 only, right? So we simply have log x square is equal to 6. This is what we are having here, right? Is it or not? Yes, okay, fine. So we are left with this steps. So finally we got log x square is equal to 6. Now what I can do is again I will use this power rule. Okay, I think it's better if we have that 2 there itself, right? Okay, we need not even disturb it. Okay, so it is better we have it without bringing it. So we will have this 2 in front itself. Okay, why? Because if we take it to the power and again bringing it, it's going to be a confusion of work. So we'll have the right hand side as 2 log x itself. Okay, now what simply we can do is 2 log x is equal to 6. We'll write like this. And now what happens to log x? Log x is equal to, it will be what? Now you can bring this 2 to the other side. If I bring this 2 to the other side, it becomes 6 divided by 2, and which is going to be 3. Is it or not? Because log x, 2 log x is equal to 6. This is like 2 into log x. Is it or not? Now this 2 will be going to the right hand side as divided by 2. So it simply becomes 6 by 2, which is going to be 3. That's it. Okay. Now it is like what? This is like log to the base 10. Is it or not? Because it's common logarithm. So it's like log to the base 10. Now what happens? Log x to the base 10 is equal to 3. So if I want to write it in exponential form, so what happens? We will get x is equal to 10 cube. This is what we will get. And hence we will have x is equal to, what is 10 cube? It's going to be 1000. So x is equal to 1000 is going to be the answer for our third subdivision. All right, okay, I hope you understood this. So this part alone we had a slight confusion. So we'll have it as it is so that it will be very easy for us to develop and then get the answer. Okay, then finally we can chase it here and then we can use the exponential form and then we can quickly solve for x and then get the answer. So x is equal to 1000 is going to be the answer. Okay, I hope you are comfortable with all the 3 questions. Yes, now we'll move on to the next question. Next we have question number 11 with us. Here also we have to solve equations. We have 4 subdivisions here. Let's try them one by one. Okay. So first subdivision we have log of 2x plus 3 is equal to log of 7. A very simple equation, right? So both these sides we have log of, and that too we have the same basis only, right? Okay. In that case what we can do? We can directly just cut the 2 logs. Okay. So we will be left with 2x plus 3 is equal to 7. So that means what? That means 2x is equal to 7 minus 3. Okay, this plus 3 will go there, it becomes minus 3. So 7 minus 3 will be 4, and hence we will have what? 2x is equal to 4. And now if we solve for x, we will be getting what? X is equal to 4 by 2, which is going to be 2. And x is equal to 2 is the answer for our first subdivision, right? Moving to the second subdivision, here also we have log of x plus 1 plus log of x minus 1 is equal to log of 24. This is what we have. So now if you see the left hand side, we can use the product rule, right? So we'll use the product rule. So what happens? We will have log of, we have one single log, we'll take it as a single log. So log of, we'll use product rule. So what happens? Since we have log of a plus log of b, that becomes log of ab, it becomes a product, okay? So log of x plus 1 times x minus 1, this is what it becomes, correct? Okay, so is equal to log of 24. This is what we will have. And now again the same thing, since this left hand side and also the right hand side we have logs, and that too we have the same basis, I can cut the two logs. So we will be having what? We will have x plus 1 into x minus 1 is equal to right hand side simply 24. This is what we will have. And before that, if you see the left hand side, what do we have here? We have x plus 1 into x minus 1. And how can you write this? This can be written as what? This can be written as x square minus 1. Is it or not? Because we know the algebra identity, right? We might have done in our school days, the earlier days, young days. So like in our 9th standard or 10th standard, you would have frequently used this. So x plus a into x minus a will be equal to what? X plus a into x minus a, I'm sorry, x plus a into x minus a will be nothing but x square minus a square. Is it or not? This identity we would have used. So here if you use it here, x plus 1 into x minus 1 will be nothing but x square minus 1 square, and that's what is x square minus 1. So this is equal to, right hand side we have 24. That's it. Okay. Fine. Now we have x square minus 1 is 24. So that means x square is equal to what? We will have 24 plus 1. Is it or not? This minus 1 goes there. It becomes 24 plus 1 there. So that means x square is equal to 25. And now we have x square is equal to 25. When you solve this equation, we will be getting what? Usually what we will get? X square is equal to 25. When you solve for x, we will be getting two values for x. Is it or not? We will be getting plus or minus 25, right? Because we have x square is equal to 25. When you try to take square roots on both the sides by our own, what happens to the right hand side? We will be getting two values for our unknown. We will have plus or minus 5. That is what usually happens. But here, since we are just playing with logarithms, what happens? We have few restrictions, right? Okay, just consider both the values. Okay, we got what? Plus 5 and also minus 5. So we got two values, right? So what happens here is, when we try to use both the values here, okay, when we use plus 5, there will be no issues. But try to use minus 5 here, what happens? When you try to use minus 5 here, the problem will be like here and here we will be getting log of negative values. Is it or not? Log of negative values, we cannot define it. Is it or not? Because log of a negative value, we can't define the answer. So in that way, what happens? The negative value what we get here will be automatically, it will be getting rejected. So in that case, we will just consider only the positive value to be our existing solution. So x is equal to 5 is going to be the valid answer. Okay, I repeat, if you take x is equal to minus 5, what happens? It affects the equation, right? Okay, we will be coming to get some log of negative values which won't satisfy, because the values we can't define log of a negative value. So for that reason, we avoid it. We take only the positive value, which is going to be x is equal to plus 5. That's going to be the answer for our second subdivision. Okay, all right. Yeah, coming to the third subdivision, here we have what? Log 5 to the base 10 plus log 5x plus 1 to the base 10 is equal to log x plus 5 to the base 10 plus 1. This is what we have. Fine. Okay. All right. So now if you see, I can use left hand side. If you see, I can use what? I can use the product rule, right? So I can use the product rule. So if we come to use product rule, what happens? We will have log of this 5 into this 5x plus 1. It becomes 5 into 5x plus 1 to the base 10, right? Okay. Yes. Is equal to, now come to the right hand side. Right hand side also, what we can do here? Here we can do log of this is x plus 5 to the base 10, right? This is x plus 5 to the base 10, and here we have plus 1. So now I am going to rewrite this plus 1 as log 10 to the base 10. Is that clear? Why? Because here this right hand side also, we will try to write it in a product form, like how we did the left hand side. The same way we try to do on the right hand side also. Okay, but for that, what do we want? We want both the terms should be expressed in terms of logarithm. That's the reason. Okay, so for that reason, what I'm going to do is I'm going to rewrite like this. Okay, this one I'm going to rewrite like this. Now it will be very easy for us to express the right hand side also in a product form. Yes, is it or not? So left hand side is log of 5 into 5x plus 1 to the base 10 is equal to, now come to the right hand side. Right hand side, what do we have? Now we will have the right hand side to be log of 10 into x plus 5 to the base 10. This is what we will have. Is it or not? Yes, clear? So now clearly if you see both these sides we have log to the base 10, log to the base 10. Okay, the logarithmic values we have expressed, both of them are expressed in terms of log, that too with the same base, and just cutting them off. So what happens? We will be simply left with 5 into 5x plus 1 is equal to 10 into x plus 5. This is what we will be having, correct? And that too here again we will do another adjustment. What we can do is, we have 5 into here and 10 into here. Let us just cut this 5 and 10 for 2 times here itself. We can do that, right? So simply we will be having what? We will have 5x plus 1 is equal to, now right hand side will become what? Right hand side becomes 2 into x plus 5. That is, bring the 2 inside. When you bring the 2 inside, we will have 2x plus 10. Right? Okay? Yeah, this is what we will have. And now we will solve for x. It's going to be very easy. Bring this 2x to the left hand side. What do we have now? We will have 5x minus 2x is equal to, and bring this plus 1 to the right hand side, it becomes 10 minus 1. So that means we will have 3x is equal to 9, and hence we will have x is equal to 3, and that's going to be the answer for our third subdivision, right? Okay, I hope the solution is clear to you. So we are just expressing both the sides as products. Okay, we are using the product rule. For that we are here making some adjustment, and then automatically everything comes. It's like just solving an equation. Okay, we solve it and then we find the value of x. X is equal to 3 is going to be the answer for our third subdivision. And last, one more subdivision we have here, fourth subdivision. Here our question is log of x plus 2 to the base 10 plus log of x minus 2 to the base 10 is equal to log of 3 to the base 10 plus 3 log of 4 to the base 10. This is what we have, correct? Yeah, okay, yes. Now we'll try to simplify this one also. Okay, here again we'll try to take the same approach how we solved the previous third question. Okay, yeah, coming here we have log of, so we have our left hand side with x plus 2 and x minus 2. So we have it to be log of x plus 2 into x minus 2 to the base 10. Is that clear? I'm just using the product rule. Okay, all right. So this becomes like this. And coming to the right hand side, we have what? Right hand side we have log 3 to the base 10 plus 3 log 4 to the base 10. This is what we have, correct? So now I can use the power rule here. So when we use this power rule, what happens to the right hand side is, shall we try doing it in a single step? Yes. I don't feel that it would hurt you much. It won't be very hard for you to understand. So we have log 3 to the base 10 plus 3 log 4 to the base 10. This is what we have. Is it or not? So I will bring this 3 to the power of 4 here, and simultaneously what I will do is I will use the product rule. Okay. So now what happens? Here we will have log 3 to the base 10 plus log 4 cube to the base 10. Do you understand that? Yes, I hope it is clear to you. So what happens? We will have log 3 into 4 cube to the base 10. This is what we will have. Fine. Okay. So I can use the power rule. Okay. I'm using the power rule and simultaneously I'm using the product rule also. Both these rules I'm using in a single step. I'll be getting this. Okay. Let me give the clarity once again. First I can use the power rule. So this 3 goes to the power of this 4. So this becomes log 4 cube to the base 10. So that means now what I can do? I have log 3 to the base 10 plus log 4 cube to the base 10. I can clamp those two using the product rule. That's what I'm just doing here. That step is what I'm doing here. Fine. Okay. All right. Yeah. Next, as usual, I can just cut this and this. Is it or not? Like how we did here. The same thing I'm doing here. And now we have left hand side. What do we have on the left hand side? We have x plus 2 into x minus 2. And this can be written as what? Like how we used here for the second subdivision. The same way here also I can use. What I can do here, I will have x square minus 2 square, because x plus 2 into x minus 2 will be x square minus 2 square is equal to, come to the right hand side. Right hand side, what do we have? We have 3 into, what about 4 cube? What is 4 cube? 4 cube is equal to 4 into 4 into 4, 16 into 4, it's going to be 64, right? It's going to be 64. All right, okay. So that means we have x square minus 4, because 2 square is 4, is equal to, again, can you multiply this? 3 into 64. 3 64s are, it's going to be 3 4s are 12, carry 1, 3 6 are 18 plus 1, 19. So we have 192 on the right hand side. So we got overall x square minus 4 is equal to 192, and that means x square is equal to what? 192 plus 4, which is going to be 196. I hope it is clear to you. So we got what? x square is equal to this 4, this minus 4 goes there, it becomes plus 4. So 192 plus 4, it's going to be 196. So we got x square is equal to 196. And finally, x is equal to what? We will have x is equal to, what answer we will have here? We will have x to be equal to, so x is equal to, we will have it to be square root of 196, right? So if you take square root of 196, what answer we will get? It is going to be how much? So if you know squares, it will be very better, right? So we know up to 12 squares usually. 12 square is 144, 13 square is 169, and what about 14 square? 14 square is what is? 196, right? So 14 square is, I'll write it separately, okay? 14 square will be equal to 196. So in that case, x is equal to, what do we get? Again, we'll get it to be two solutions. We'll get plus or minus 14, but the same thing, how it happened here, the same thing happens. When you take the negative value, it will be not satisfying the question's condition. Why? Because negative value, the logarithm of negative value will not exist. So we'll just reject the negative value. We'll take only the positive value 14. So x is equal to 14 is going to be the valid answer for our fourth subdivision. This is going to be the answer. Okay. I hope all the four subdivisions are clear to you. Yes, move on to the next question. Question number 12. Another interesting question is with us. We'll see it. If log of x minus y by 2 is equal to half of 1 by 2 of log x plus log y. So this is what is given. Okay, this is a given condition. Okay, then we have to prove that x square plus y square is equal to 6xy. This is what we need to prove. So we have to take this, we have to do some kind of steps. We have to just solve this, and finally we need to prove that x square plus y square is equal to 6xy. This is what we are expected to do. So yeah, let us start from here. So this is what is given here, right? So we are given what? Log of x minus y whole divided by 2 is equal to, here right hand side we have 1 by 2 into log of x plus log of y. This is what we have, right? Okay. So first step, what I'm going to do is I'm going to start from here, and the first step itself, let me just do some adjustment. Okay, I will bring this 1 by 2 to the left hand side. So what happens if you try to bring this 1 by 2 to the left hand side? It becomes 2 into log of x minus y by 2. This is what it becomes, right? Is equal to, now what will be the right hand side? Right hand side will simply have log x plus log y. This is what we will have. I hope you can understand this. I'm simply taking this 1 by 2 to the left hand side so that it becomes 2 into, okay, because this 1 by 2 comes here, this becomes 2 into log of x minus y whole divided by 2. Yes. Next thing, I can use the power rule here in the left hand side, right? I can use the power rule. So when I use power rule, what happens? So this is 2, right? This 2 goes to the power of this log value. Okay, what I have here, the log value, I have this expression here. Now this 2 goes to the power of this expression. So now what happens is log of x minus y by 2 the whole square, it becomes the whole square, is equal to, now come to the right hand side. Right hand side, what do we have? Right hand side we have log x plus log y. So here what we can do is we can use the product rule, right? So we'll use the product rule. So we get log of, what do we get here? We will get xy, simple, log of xy. This is what we'll get. I hope you can understand this. So left hand side I used power rule so that I will get what? I will get this x minus y by 2 the whole square, I get like this, and right hand side I'm simply using the product rule. So log x plus log y will become log of, it will become the product, right? It becomes xy. That's it. Now very simple. Now both these left hand side and right hand side, both the expressions we have in terms of log of and log of, now I can cut it, right? So because log of some entire expression, log of some entire expression, I can cut this and I will have this one. I will be left with this expression. So now what I will have is, I will have this square we will distribute to both numerator and denominator. So what happens? We will have x minus y the whole square divided by, here denominator will become 2 square. What about 2 square? 2 square will be 4, right? 2 square is 4 is equal to, right hand side we will simply have xy. Correct? Yes? Yeah, okay. Now what next I can do is, now I will expand this x minus y the whole square. If you expand x minus y the whole square, it becomes what? X square plus y square minus 2xy. This is what we'll get, right? Because we know the identity for a minus b the whole square, it is a square plus b square minus 2ab. The same thing will happen here. X square plus y square minus 2xy. Okay, and we have divided by 4. The whole thing divided by 4 is equal to xy. Now what we will do is, we will bring this 4 also to the right hand side. So what happens now? It will become 4xy. Is it or not? Yes. Okay, So I hope you can understand this. Numerator alone I am just expanding using the algebra identity, and denominator I am going to take it to the other side so that it will become 4 into xy, so 4xy. That's it, right? So what next it happens is, now it will happen like x square plus y square is equal to, now it's going to be very simple, x square plus y square is equal to, now this minus 2xy you can take it to the right hand side. So what happens? It becomes 4xy plus 2xy, and thus it becomes x square plus y square is equal to, what about 4xy plus 2xy? It's going to be 6xy. Simple, right? That's it. So this proves the given statement which is given in the question. Okay, so hence we have successfully proved what we are asked to prove in the question. Yes, okay, it's going to be very simple. We are just using the product rule, power rule, the usual laws of algorithm, nothing else we are using, and we are using the algebra identity for the expansion, and then we are simplifying to get the answer. So that is giving us the proof. Okay, so this is going to be the proof for our question number 12. Let's move on to the next question. Next we have question number 13, which is going to be very similar to the previous question which we just solved, question number 12. So, but this one is going to be quite little different. Why? Because here we are asked this question in a way like it is going to be the reversal way of what we have tried the previous question. Okay, so see the question. Here it is given that if x square plus y square is equal to 23xy, okay, if x square plus y square is equal to 23xy, then prove that log of x plus y whole divided by 5 is equal to half of log of x plus log of y. This is what we are asked to prove. Okay, so if you have noticed the previous question, there we had like given this part and we need to prove this part. But this question, question number 13, we are having it like given this and we need to prove the logarithmic form. This is what we have done. Okay, so we should be little careful here in proving it. Okay, so we'll start from what is given to us. Okay, we are given x square plus y square is equal to 23xy. This is what is given, and now instantly what we will do is, the next step itself what we will do is, we will just add 2xy on both the sides. We will add 2xy to both the sides. I hope the step is clear to you. So what I'm doing is x square plus y square equal to 23xy we have here. So plus 2xy and plus 2xy. Both these sides I am going to add plus 2xy plus 2xy. This is what I am doing. Okay, fine. Now if you see the left hand side, what do we have here? Here we have x square plus y square plus 2xy, which is nothing but this is the expansion of what algebraic expression? This is going to be x plus y the whole square. Is it or not? Fine. So all we have is x plus y the whole square is what is equal to. Now come to the right hand side. Right hand side we have 23xy plus 2xy. So we have 25xy. This is what we have. Fine. Okay. Yeah. Yes. 25xy. And next what I can do here is, now I will just bring this 25 to the left hand side. So this 25 is like with multiplication here on the right hand side. Now when it comes to the left hand side, it becomes x plus y the whole square divided by 25 is equal to, right hand side we will only have xy. Yes, is it clear? Yes. Yeah, I think it is clear to you. Fine. Now see the right hand side, we are left with only xy there. So why we are doing all these steps is, our plan is leaving this x and y alone on the right hand side. Why? Because see our proof also. The proof part also, it contains only x and y on the right hand side. That's why. Okay, yes. And this x plus y part is on the left hand side. That is what we are leaving this x plus y on the left hand side. Fine. Okay, yes. Next what we can do is, we will just have this x plus y the whole square divided by 25. This 25 I am going to adjust now. How am I going to adjust it? I am going to adjust it as x plus y the whole square divided by this 25 I am going to write as 5 square. I can write like, because 25 is something but 5 square, this is equal to xy, and let us just continue here on the right hand side. Okay, we'll just continue the steps there. So we are left with x plus y the whole square by 5 square equal to xy, and now what we can do? Here we can just do it like, x plus y the whole square by 5 square. I'll take the whole square now. Okay, so I will write as x plus y by 5, x plus y by 5 the whole square. We'll write like this. You can very well write like this, right? Because the square is going to be common now. I am going to write it as the entire fractions whole square. That's it. Okay. So x plus y by 5 the whole square. That's what I am writing here. Is equal to, right hand side is going to be xy. The same thing happens. Right. Now let us now do the thing. Okay. Now we will introduce logarithm. Okay. We will take log on both sides. Okay. We will take log on both sides. So when you take log on both sides, what happens? Both the sides will have log of x plus y by 5 the whole square, and here the right hand side it becomes log of xy. This is what it happens. Clear? Done? Yes? Okay. Now we have applied logarithm on both the sides. Now we will use the power rule. Left hand side we will use the power rule. When you use power rule to the left hand side, what happens? The left hand side becomes 2 times of log of x plus y by 5, and come to the right hand side. Right hand side, what happens? Right hand side we have log of xy, and here we can use the product rule. Okay, when you use product rule, what happens? We will have log x plus log y. This is what it happens. Clear? Yes. So left hand side I am using product rule. Left hand side I am using the power rule. Left hand side I am using the power rule. Right hand side I am using the product rule. This is what I am doing here. Fine. Okay. All right. Yes. This is okay. And last one step we need to perform. What we can do is, we will just take this 2 to the other side, so that this multiplied by 2 will go there as divided by 2. Alright, okay. So log of x plus y by 5 will now be equal to, this 2 goes there on the right hand side and it will simply become 1/2. So 1 by 2 of the right hand side, the values log x plus log y. Simple, right? I think now this statement is what is given in the question. So we are able to prove it. Okay, we have successfully proved the given statement, what is given in the question. We have exactly proved it. Log of x plus y by 5 is equal to half into log x plus log y. That's it. Okay, so if you clearly observe, we have just done the steps in the reverse way. What we did in the previous question, we have just done it in the reverse way. Okay, we are just doing the reverse process there here to achieve this proof. That's it. So you can just easily compare this question with the previous question. So this is going to be a very easy proof only. Okay, just we have to adjust, we have to take some things, the log and everything, using the properties, we will be easily able to prove it. Okay, that's all. This is all about this proof for this question, question number 13. Now we'll move on to the next question. Coming to question number 14, here we have to prove that following two subdivisions. We have two statements given here, two expressions, we need to prove them. And to prove these two statements, these expressions, we need to use the change of base rule. We have seen in the introduction part itself, right? At the beginning of this video itself, we have seen about all the rules. There at the end, we saw about this change of base rule. Do you remember? The change of base rule is what we need to use here to solve these two problems. Okay, all right, yes. So let's revise that. What are the rules? Log a to the base b multiplied with log b to the base c will be equal to log a to the base c. This is what we have seen there, right? So what happens there? When you have here this base and this base and this log value, we have, they both will be cancelled, and what happens? This log a to the base c will be appearing as the answer. That is the first rule we have seen. And what about the second rule? Second rule will be log a to the base b is equal to 1 by log b to the base a. Or the reverse way also, if we have 1 by log of a value to some base, we can just swap it. Okay, we can swap it. So these are going to be the two rules we are going to use here to solve these two questions. Okay, yeah, coming to the first subdivision, we have to prove 1 by log of abc to the base a plus 1 by log of abc to the base b plus 1 by log of abc to the base c is equal to 1. So we'll start from the left hand side first. So left hand side we have, so I think I can write it once again, 1 by log of abc to the base a plus 1 by log of abc to the base b plus 1 by log of abc to the base c. This is what we have. So this is equal to, now I can use the second rule what we have here. We can use that, right? So we have 1 by log of a value to some base. What we can do? We can just change the base and the value, right? So what we can do now is we can just change it. So if we change it, what happens is the first expression we will have log of, log of log ABC to the base A will now become log A to the base ABC. Is the point clear? That's what we have just taken the reciprocal, right? Once you take the reciprocal, these two values will get interchanged. Okay, so this is what will happen. So plus 1 by, same thing for, I'm sorry, not 1 by. Okay, so same thing happens here also. Okay, so here 1 by we have this. So now what happens is this becomes log of B to the base ABC and plus log of, here this becomes C to the base ABC. Now what I can do here is, since we have log of values which are added, we can directly use the product rule. So if we use product rule, what happens? Log of what happens? So this will be what? A, B and C. They all will be getting multiplied. So we will have log of ABC, A into B into C, which is going to be ABC, to the same base. Base is going to be common, right? So to the base ABC. Now what happens to the value of this one? What is log of ABC to the same base ABC? It's of course 1. 1 is going to be the answer, right? So that means this is going to be our RHS. So this proves the first subdivision. All right, okay. Now coming here to the second subdivision, here what do we have? So here we have our LHS to be log of A to the base B plus log of B to the base C, sorry, multiplied by log of C to the base D. This is what we have in the LHS side. So now what we can use here is we can use the first property of our change of base rule. We can use that one. Okay, so once we use that, what happens is, here this left hand side we will handle two terms. Okay, we will first handle the first two terms here. So what do we have here? Here we have log A to the base B multiplied by log B to the base C. So now if you see, here we have base B and here we have the log value B. So they both will be cancelled. So we will be left with what? Log of A to the base C. We will have log of A to the base C. I hope it is clear to you. So log of A to the base C into, next one we have what? Log of C to the base D. Okay, fine. Yes, this is what we have. Now once again we will try to use the change of base rule by multiplying these two terms. Okay, now if you multiply these two terms, now here we have base C and here we have value C. They both will be cut, and now what happens is log of this becomes log of A to the base this D. That's it, very simple, right? So just we are using the rule twice, we are able to simplify the given expression, and this is what we have on the right hand side, right? So log of A to the base D, that's what we have here on the right hand side. So this is equal to RHS, and hence we have successfully proved both the given statements of this question number 14. Yes, okay, yeah, this is clear to you, I think. Let's move on to the next question. Next we have question number 15 with us. Here given log x to the base A is equal to 1 by alpha, log x to the base B is equal to 1 by beta, and log x to the base C is equal to 1 by gamma, and we need to find the value of log x to the base ABC, the product of A, B and C. So this value is what we need to find. Okay, yes. So as usual, first of all we'll start from what is given to us. If you see here, we are given three data, right? So log x to the base A, x to the base B, x to the base C. So we are given three values, and we will start from there. So we will start from first this value. Okay, log x to the base A is equal to 1 by alpha. So first thing what we will do here is we will take the reciprocal. Okay, we will just take the reciprocal in this expression. So what we will be getting here is we will be getting 1 by log of x to the base A is equal to alpha. This is what we'll get here, right? Yes, because if we take reciprocal on both the sides, this side will become 1 by, and this side 1 by alpha will simply become alpha. That's it. We'll do the same for the other two, right? Yes. Okay, here this expression will become 1 by log of x to the base B is equal to beta. Is it or not? Yes. And next, the third one, here we have log of, we have 1 by, 1 by log of x to the base C is equal to gamma. This is what we will have. Alright, yes. Okay, fine. And now with the change of base rule, what we can now adjust here is we can now rewrite this 1 by log of x to the base A as simply log of A to the base x. We can write like this, right? So that means we'll get log of A to the base x is equal to alpha, and next we have log of B to the base x is equal to beta, we'll have it like this, beta, and next we will have log of c to the base x is equal to gamma. This is what we'll get. Alright, yes, fine, yes, accepted. Now we got these three expressions. Now we will do one thing, okay. Now we got three expressions here. Let us try to add all these three values, okay. So when I try to add the values, we will be getting log of a base x plus log of b to the base x plus log of c to the base x is equal to, and what about the right hand side? Right hand side will become alpha plus beta plus gamma, right? Yes. See here, I am just adding all the left hand side values. Left side, left side, left side. So we have log, log, log. These expressions will come to the left hand side is equal to, now what about the right hand side? Right hand side we have alpha plus beta plus gamma. That's it. I am adding the left hand side three values, that will be equal to the right hand side three values. That's it, simple. Okay, fine. And now again coming to this left hand side, we can use what? Here we can use the product rule. Is it or not? Why? Because see here we have three log quantities, they are getting added with the same base, so we can very well use the product rule, right? Now if you use the product rule, what happens? Log of, now we will have the product, right? A, B, C, they will be getting multiplied now. So we'll have log of A, B, C to the same base x is equal to, what will be the right hand side? Right hand side will have alpha plus beta plus gamma. This is what we'll have, correct? And now once again what we will try to do is, we will take the reciprocal on both the sides. Okay, let's try to take reciprocal on both sides. So what happens? When you take reciprocal on both sides, we'll have the left hand side to be log of 1 by log of ABC to the base x is equal to 1 by alpha plus beta plus gamma. This is what we'll have. And just last one step, just see what do we have in the left hand side. We have 1 by log of ABC to the base x. Now when we have a reciprocal, what happens? These two values will be interchanged. Is it or not? So that means we will be having finally log of x to the base ABC. Okay. Now it is no more 1 by. So since we have 1 by this value, this becomes what? This becomes simply log of this x comes here, this ABC goes to the base, right? So log of x to the base ABC will be equal to 1 by alpha plus beta plus gamma. So that means the value for what is asked in the question, log x to the base ABC, that is what is asked in the question, right? Find the value of log of x to the base ABC. So the answer is going to be 1 by alpha plus beta plus gamma, and that's going to be the answer for this question number 15. Alright, yes. Now we'll move on to the next question. Now we are with question number 16, and this is going to be the last question of this exercise. Here we got two subdivisions, and here we have to solve for the value of x. Let's take the first subdivision. Here we have log x to the base 3 plus log x to the base 9 plus log x to the base 81 is equal to 7 by 4. We have to solve and then get the value of x. This is the question. Okay, fine. Now if you see this expression, we got all these values to be log of x, log of x, log of x, but we have the bases to be different, right? So in that case, we cannot directly use the product rule. That is not possible. Product rule we can use only when we have the same bases. Correct? So here we can't directly use the product rule. That is not possible. So now what we can do is, we'll just try to transform it. Okay, we'll just try to transform it, and we will use the change of base rules, that rule what you have seen there. Okay, so let's try to use that. Now what happens is, if I use the change of base rule, I will try to write it as a reciprocal. Okay, so log of x to the base 3. Now I will write this as 1 by, so once you write it as 1 by, what will happen? Now this will become log of 3 to the base x. Is it clear, right? Because this base and the logarithmic value, they both will be getting interchanged. Okay, so log x base 3 will be written as 1 by log 3 base x. That's it. Okay, same way, plus 1 by, this also will write the same way, 1 by log. Now what happens is 9 to the base x. Is it or not? Because here we had x to the base 9. So when you try to write as a reciprocal, what happens is, this will become log of 9 to the base x. That's it. Okay, plus 1 by log of, this one will become 81 to the base x is equal to 7 by 4. So this is what we have, right? Okay, fine. Now next what we can do here is, we'll try to have this one as 1 by log 3 to the base x. This will be as it is. Okay, let us have this one as it is. But now this one we'll try to write as 1 by log of, okay, here we have 9 to the base x, right? This 9 we will try to rewrite it as 3 square to the base x, because here we already had 3, right? Now this 9 I am going to rewrite it as 3 square, okay? Same way, 1 by log of this 81 I am going to write as 3 to the power 4 to the base x is equal to 7 by 4. We will write like this. Alright, okay, fine. Now what next we can do here is, we will just use power rules here and here, because we got 3 square, 3 power 4, right? So we can very well use power rule. So when you try to use power rule, what happens? 1 by log of x to the, 3 to the base x plus 1 by, now this will become what? This becomes, this 2 will come to the front. So this becomes 2 to the log, 2 log of 3 to the base x plus 1 by, now this will become 4 times of log of 3 to the base x is equal to 7 by 4. This is what it becomes. I hope so far it is very clear to you now. So this 2 is coming to the front here and this 4 is coming to the front here. That's it. This is what happens. Now clearly if you look at the denominator, what we have is, we have everywhere log of 3 to the base x, log of 3 base x, log of 3 base x. So I will remove that 1 by log of 3 to the base x. Now what I will have inside? Inside I will have what? Since here we have taken the entire thing, we will have 1 plus here we will have 1 by 2 plus here we will have 1 by 4. This is equal to 7 by 4. This is what we will have, right? Is it or not? Yes. Now once again, we will try to operate this. What is 1 plus 1 by 2 plus 1 by 4? Try to work it out. This will be nothing but what? If you take the LCM and see what happens. So we'll just try to work out this separately. So if you take the LCM, what happens? You will have the grand denominator to be 4. And what happens here? 4 plus 2 plus 1. That's what will come. So that means we will be getting here what? We will be getting 7 by 4. So we will have 1 by log of 3 to the base x into 7 by 4 is equal to 7 by 4. This is what we will get. Is it or not? Yes, clear? This is what we will get. And so finally what we will get? We will just cancel these two terms, okay, because both these sides you have 7 by 4 and 7 by 4, right? I hope it is clear to you. This is just a simple fraction simplification, okay? So 1 plus 1 by 2 plus 1 by 4 can be simplified as, when you take the common denominator as 4, when you take LCM 4, and if you try to raise the numerators also, what happens? 4 plus 2 plus 1, that will become 7, 7 by 4. So 7 by 4 and 7 by 4, what we have on both the sides, they both will be cancelled. So finally what we have? Now what we have here? Now we will be getting 1 by log of 3 base x is equal to, right hand side is 1. So that means log of 3 to the base x is equal to 1. This is what we are getting. And now when you try to write this as an exponential form, from there itself you can easily get the answer. What do we get now? X to the power 1 is equal to 3 and hence x is equal to 3. This is going to be the answer for our first subdivision. Okay, alright. So just have a view, you can easily understand this. Okay. So just a small adjustment using the change of base rule. That's what we are doing here. And that is helping us to take the things common. And once you take a common, you will have only fractions inside and you add it, you just cancel it and then you can easily solve for the value of x. That's it. Okay. Now the same way is what we are going to work out the next question also, the second subdivision also. Alright. Okay. Yes. Let's see what do we have here. Here we have log x to the base 2 plus log x to the base 8 plus log x to the base 32 is equal to 23 by 15. This is what we have. Correct? Now here also we are going to use the same technique. Okay, what I am going to do is, here also I am going to write as 1 by log of 2 to the base x plus 1 by log of, what do we have? 8 to the base x and plus 1 by log of 32 to the base x is equal to 23 by 15. This is what we'll get. Yes, okay, fine. And next what we can do here is 1 by log of 2 to the base x and 1 by log of, as usual, here how we try to write these terms as 3's powers, here we'll try to write as 2's powers. Yes, we'll do that, right? Here we got 8, right? So how can we write this 8? This 8 can be written as 2 cube to the base x plus 1 by log of. What about this 32? 32 is what? 2 to the power what? Will give you 32. It is going to be 5, right? So that means we'll have 2 power 5 to the base x is equal to 23 by 15. And as usual, what we can do? You'll use the power rule. Okay, we'll use the power rule. So we'll have 1 by log of 2 base x plus 1 by, this 3 comes to the front. This becomes 1 by 3 into log of 2 base x plus 1 by 5 into log of 2 base x. This is what we'll have is equal to 23 by 15. This is what we'll get. And what next we can do here is, as usual, we can now take these common terms outside. But they are in 1 by form, so we'll have to take it as 1 by only. Okay, 1 by log of 2 to the base x. If you remove it as a common factor outside, what we'll have inside? We'll have 1 plus 1 by 3 plus 1 by 5. This is equal to 23 by 15. This is what we'll get. And what next I can do? 1 by log of 2 to the base x. Now, you just try to simplify what we have inside. What we have inside? 1 plus 1 by 3 plus 1 by 5. So, when you take the common denominator as 15, now what will happen? What happens here? We will have 15 plus 5 plus 3. I repeat, I will take the LCM 15, okay, because we got the denominators 3 and 5. So, if you take the LCM 15, I will take the common denominator as 15. So, now what happens? This will become 15. This numerator 1 into 15 will become 15. And here we will have 5 and here we will have 3, correct? So, 15 plus 5 plus 3 will become what? It's going to be 20 plus 3, that means 23. So, overall we will have 23 by 15. So, this 1 by log of 2 base x into 23 by 15 is equal to what we have on the right hand side. Right side also we have the same 23 by 15 only. So, that means as usual you can cut these two. And now what we can do here? We can just do 1 by log of 2 base x is equal to 1. This is what we have, right? So, we have 1 by log of 2 to the base x is equal to 1, or otherwise we can even write it directly as we wrote here. So, log of 2 to the base x is equal to 1, we can write it. And now, if you want to find the value of x, what you can do? X power 1, you just try to write this logarithmic form in terms of exponential form. We'll have x power 1 is equal to 2, and that means x is equal to 2. So, x is equal to 2 is going to be the answer for our second subdivision of this 16 question. Okay, alright? Yes, fine. So, yeah, both these questions are over, completed. Yes, all of you, I hope you are very clear with the way of solving all the problems from this exercise are clear to you. And as usual, if any doubts, you can just leave it in the comments. And when I see it, I'll just see to rectify your doubts also. Yes. And yeah, if you feel this session to be useful, please give a like. And also, if you feel that this session would help any of your friends, please do share this video to your friends also. Yes, and again we'll catch up in the next session with some other exercise solving problems. Okay, exercise problems or concept, we'll be solving it there. See you soon there. Thank you so much.